Took the way you saw the world. Then
All right, hello and welcome, ladies and gentlemen. Tonight we're going to be joining the Levelheads HQ Flat Earth Fridays crew on Twitter Spaces for a live kind of Q&A and back and forth. They have a diverse group over there of Globers and flat earthers and stuff, and so there'll be a lot of back and forth and questions and commentaries. So it should be an awesome interactive night. Let me make sure I'm live on Kick. And I also wanted to promote. Should be live on Kick. I want to start seeing if I could grow on there. There we go. Yep, live on Kick as well. So if anyone has a Kick account or whatever, we'll be live there. That's a popular site for where the youngsters go to congregate and stream the video games and whatnot. So figured I'd start a flat Earth presence over there in the podcast section. So if you're able to register an account and hit a follow over there, that would be greatly appreciated. But anyway, I'm gonna unmute on Twitter here, and we'll see what the boys are up to. I think they're still doing their intro though, so we'll see. Let's see what's up with them.
Horizon means horizontal. Indoctrination is awful because you're taught the global.
Yep.
Ever since y'all could, we follow rapists and murderers, liars, thieves, and sun worshippers. Retweet the space. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, not at all. It's a criminal enterprise where deception intensifies.
Yo, what's up, Mrs. Tribune? How are you tonight? Need to get you another 150 subs so we can get the double money. Yeah, man. I'm actually good on the subs. I need watch hours now. I'm at like 2,800 out of 3,000 watch hours. So if you guys want to go ham and just leave me running in another browser, hit me up or whatever.
Oh, we going crazy tonight.
Yeah.
They try to do all the humans this way. So are they just idiots? Who is to say? Conditioned by the television, it makes your decisions, opinions, and you just obey. Stuck in the material domain of Satan, where everything in each and every day is pagan. Mandela effect, because the game is changing.
All right. I haven't told the boys yet on Twitter, but Shane was going to join us tonight, but he had a family emergency that just popped up, so he's not going to be able to make it tonight. So thoughts and prayers to him and his family, and you can reach out to him and find out more about what happened and whatnot. But that's the situation with Shane, so he won't be here tonight. He's okay. It's family member situation, but anyway, I'm gonna let them know here in a minute. But you guys all know Shane, so I figured I would let you guys know first. Hell yeah, that's what's up, dude. Let's see.
I'ma keep it G like gravity. All I see is density and buoyancy. Wake up to your new reality.
Crocheting, dude. It took me a minute to decipher that word. I was like, I'm like, I know she's definitely not crotcheting, so it's definitely not that. So yeah, crocheting sounds like that's what that word spells.
Once upon a time,
So
it was all just one big
got
lie.
that. Close that out.
New reality. The globe is
Oh yeah, let me see if I can
Because
pull
it
the
has
boys up on here.
really got a lot of nerve. I
How
think
do
I see
I?
Waldo before I see the curve.
I think Waldo was in here.
Gravity, Einstein.
Yeah, I'll just leave it up like this.
Thing of
I can't be
space-time.
bothered to fucking
What happened to the baseline?
crop it out and move it over. That was annoying last time.
Okay, fine. Nah, man, but the globe's already been proven. Oh, my bad. I didn't realize you were that stupid. What do you mean? I studied it in college. Oh, you mean that blue pill you call knowledge? Are you ready to step out of the matrix? Are you just too dumb and complacent for this to make sense? I'ma keep it G like gravity. All I see is density and buoyancy.
Keep it G.
To your new reality, the globe is fake and it's based on a fallacy. Shout out to the flat earth haters getting flat smacked every single time they debate us.
I haters.
Reality, the earth is flat and
We
there's
love
no
you,
proof of
Globy.
gravity. Wait, what? Oh,
I said.
oh no, I was talking about the theory of gravity. Like this one? Nah, not at first. You're gonna learn to though.
How y'all feeling tonight?
If you believe we put a man on the moon, you probably believe we're gonna
It's about that time, y'all. It's about that time.
to be the bearer of bad news, but that's just
All right. While they're doing their intro, I'm gonna play a couple of videos that I found earlier this week that are awesome. So they're in regards to the Sagnac effect. What's this guy's channel name? Palunum88 or something like that. Palunum. Wow. Yeah, Palunum. That's not the guy's channel. What the heck is his channel name? 1 second. This is gonna bug me now. Oh, Pelnum. Plenum. Oh, Plenum 88. There we go. All right. So we have some interesting reference frame perspectives here. So I was talking to I Can Science That the other night. We had a pretty awesome conversation in regards to the ether wind and its propagation and the geometry of it. It's a really good, insightful conversation. Learned a lot. And one of the big things to note from this, here's the link if you want to check it out or whatever. But one of the big things that was noted from here was the where's this? I don't have the yeah, here we go. This thing. Cool. Yeah, so the geometry of the ether wind and how it would follow the toroidal field on a flat plane. And obviously, the toroidal field would be generated by the charge from the sky, and then the ground being low potential, right? So that whole situation would, following the right hand rule, would generate the magnetic field, and that toroidal field, the ether would follow that motion within that. So to follow that, in regards to like aligning the gyroscope axis or whatever, just so that it would be symmetrical. It would, to match the globe. The ether wind would be following the inner donut and the outer donut of the toroid. So very cool stuff there. And then there was some comments made on the Sagnac effect. How it's I said that it's not a relativistic effect, and he said that it was a relativistic effect, and then obviously that's how they teach it in physics books and whatnot. So, of course, that would be the default position for him. But there was something in regards to like what happens on like is the observer in the lab seeing the speed of light difference, or is that the observer in the non-inertial frame being the rotating device that's experiencing the variance in the speed of light and all that? So this guy, whose channel I've come to before for a lot of SAGNEC stuff, he actually did two experiments where we get live observations from the observer's perspective to see what happens to in regards to the variance of C. So we'll watch that while they're doing their intros. Still, we'll check in on them to see if they're still introing.
The science. We are not running from any smoke. If you have any ad homs to contribute, please wait until you grab a mic to say it with your chest. I am proud and your host, Sacred. Welcome to Flat Earth Friday.
Oh, we're live. We'll go over the SAGNEC stuff at the end if I remember.
What's up, what's up, what's up, what's up? Episode 71, Flat Earth Friday, Sacred Spaces. I see the level heads in here. Ethereal Physics Part 4. Man, it's good to see y'all, man. Felt like time dilated or something. What the hell?
Only when we making content last minute.
Hey, y'all know the deal. Elon hating on me. I don't got no purple pill. No chat. So I went ahead and shared the space up at the top, right? Feel free to comment, tweet at us about the topic at hand. Looking forward to hearing from you guys. Also, check out the pinned tweet. We're going to get into a little bit more of these ethereal physics, interferometry. A lot of misinterpretations of the science. I feel like we had a great discussion last week, and I definitely wanted to continue the conversation this week. So shout out for y'all pulling up. First and foremost, I want to say shout out to Alan. He back in the building again. What up, my guy?
Yo, what up?
Good to see you, bro. Dude,
it's good to be. It's good to be back.
The level has loved you, man.
Yeah, man. It was great coming through. Shane was going to come through tonight, but unfortunately, there was a last minute family emergency, and he won't be able to come on tonight.
Hey, prayers of Shane, man, and shout out to Shane St. Pierre. A lot of great knowledge over that way. The first time I spoke with him was on Discord. Yeah, man, what a wealth of knowledge. Built a dope community. I think he's more on Telegram now. I don't know if he's on what Discord server he's on, but you guys put out some great content, man, for real. So prayers out to him.
Yeah, yep, absolutely, man.
Who else we got in the building today? We got Ted and Bill and Dev. Shout out to Rufus. He might be asleep over there on the other side of the plane. Hey, if y'all haven't seen it yet, we popped out with a podcast. Shout out to the Phone Booth Pod. Let us know how y'all like about that, man. We have so much fun. Bro, those guys are comedians, bro. Flat earthers with a sense of humor. It don't get no better than that. Hey, I told Ted, I don't know how he been all that space-time fitting us all in that phone booth like that, but that was impressive. Y'all go check them out on YouTube and on Rumble, man, Phone Booth Pod. I went and retweeted it, some of the links. Y'all go check it out, man. It's just dope. I see Ken in the building. What up, Ken? Banksy in here, TM. I see Moody in here, Jason Bourne. What up, Jason? F Guy Facing. What up, Facing? Canadian in the building. My man Glow in here. Non-rev. Individual. Where's Waldo? Should we find Waldo? He ain't hidden behind the curvature. That's what's up. Cug in the building. Level Liquid. Shazzy, what up, Shaz? We got Leo in here. We got Karen, Tim, Bo. Sonny, we got Jason in here, Rubio, Troy, Antonio, Turtle Express, Herbal, Carla, my man Rusty, Nick slid through, of course, Surfing Bit, Peace. We got Looking G, Looking Glass. We got Red. We got Ironside and Coca. Welcome to Flat Earth Fridays, man. Appreciate y'all pulling up. And like I said, at your favorite Globie, Tell another true earther we live. We don't miss a week. We here with it. I think I'm rugging.
Yeah, man, interesting nights. As we said, Shane was gonna come through with Alan. Definitely a couple things to break down. It's about the ether. It's about Michelson-Morley, Aries failure. Just more experiments that further prove the globe to be trash. And yeah, so I can't wait to get into it. I'm gonna be taking notes right along with some of y'all. I don't know. Do you want to get into it, or are we gonna bring some of the gang up to chat? Hold on, let me check. We had hella globe tards in our mentions. Well, of course they're not in here right now.
Dude, they had some really good questions at the end last episode. So, I guess save them up for the end then.
Oh man, that's what that's their specialty. Popping shit at the last minute, talking mess, but not coming to actually hear the response. I think they're still active. If you get those notifications, you'll see. Alan, they're in the mentions heavy.
Oh, dude, I had to turn notifications off. It
Oh.
got crazy on day one. Brenda hit me
Oh
up back to back like 9 times in a row. I was like, yeah, dude, I gotta turn that off. So
yeah, we've met the force of Brenda. That's for sure.
yeah, good times.
Brenda actually wasn't that bad, to be totally honest, after you left. I don't know what calmed her down, but it was a little bit of balance in here. I was surprised about that.
Nice.
But shout out to all the Glovers that do pull up. They did have a lot of great questions at the end of that last space. I don't know why they're not pulling up and actually coming to have a conversation, but let's give them some time to build up a little bit of courage.
Yeah.
So we had like a lot of questions from last week. Well, first of all, we had a lot of positive feedback. And they said a lot of the content that you dropped was super educational. A lot of them hit me, said that they went to your YouTube and tapped in, trying to get a little bit more information. So I definitely wanted to continue the conversation because, I mean, even myself, I learned a lot, which was dope, bro. It's like as much research as we do, we 71 weeks in, and still being able to like share ideas and learn stuff from each other. It motivates me so much to keep on pushing forward, to figure out the details of all this information that they're pulling out. And it was great going through a lot of your content, man. And I wanted to kind of like touch on a little bit more, especially some of the interferometry aspects. I really want to make sure that everybody is fully aware because, we got new listeners in here. We got a lot of repeat listeners, but some people pop in for the first time. So not a lot of them know about, some of these instruments that they're using to give us certain interpretations when it could be completely different. Michelson-Morley, Michelson-Gale, Aries failure. And what was the other one? The fourth one was...
Oh, there was there was Aries failure, Michelson-Morley, Michelson-Gale-Pearson, and Dayton,
and Sagnac.
Dayton Miller and Sagnac, yeah.
Yeah.
Yep.
So it seems like, well, first of all, there's history to the way that these sciences have played out, right? And I think that's important, when we're having these discussions about how things developed. And as I was going through a lot of Alan's content, he broke it down really well. There's so many connections between, we touched on a lot of it last week, but kind of like intervals. And I kind of want to get down a little bit more basics because, I mean, for first and foremost, I didn't even ask Alan, like, what was your, like, how do you interpret on a basic level of understanding of what the ether is? Just so everybody has an understanding of your interpretation.
So a really easy way that I kind of conceptualize it is just like, so the concept of what they measure, right? Specifically being the speed of light varies when it's going, east and west. So it's as if it's going, upstream and downstream. So the way I kind of conceptualize it is that there's just like a uniform motion, right? But obviously, there's a degree of variance to it. but it's more or less just going, in the same direction, and it's the equivalent of going upstream and downstream, right? And it's just carrying all that motion from the uh, what's it called, the from the from the sky above us, right? It's just translating all that motion, because what they measure in the variance in the speed of light is that when they plot it against sidereal time, the fluctuations match the movement of the sun. So basically, as the speed of the sun is fluctuating to maintain 15 degrees per hour in the sky as it travels in the northern and southern hemispheres during the equinoxes, there's a speed variance that's matching. So not only does like light go faster, but like depending on the time of year, right? Or yeah, it goes like slightly faster, like it peaks and then it goes back down, and that's crazy. So like that's kind of way I imagine it's just like it's following like a river, right? It's just going upstream and downstream essentially.
Yeah, right. So, and what I found was interesting was, you were speaking on the variance of the speed of light, and how I guess when a signal is coming from the source, when that source is moving, it's not going to affect the speed of light, but it's quote unquote the speed of light. But
Correct.
when the receiver moves, that's when we run into issues.
Yep. Yeah.
And we
Yeah.
had like a lot of conversation when it came to like ECEF, which is the Earth Centered Earth Fix. But what I learned from you last week was the ECI portion of it, which I think that is like the most important part of that conversation, because it seems like they have all of these formulas and calculations built in the first, what do you call it, like the first measurement, the first
Yeah, so the first order measurement would be
first
the,
order of
the
measurement.
the first measurement that it takes, but it doesn't require any corrections in it or anything like that. It doesn't require for them to say like, oh, due to refraction or due to XYZ, we have to adjust this variable. It's none of that. So like in terms of GPS, it's like a rare occasion where they get a first order measurement where they don't have to make any assumptions or corrections because of the way it works. The equation that they use. And then GPS being a time interval system, they just use a range measurement equation, and they're just basically taking like the fixed speed of light that they assume is fixed, and it gets there when it encodes that timestamp of when it's sent. So when the receiver gets it, all that has to know is like where the satellite or was when it sent the signal, right? So it's very simple and straightforward. And what they found when they take that measurement in the ECI reference frame, right? So a stationary non-rotating reference frame specifically, and they what they say is that this is stationary relative to the center or to the center of Earth, right? Or axis of rotation, right? But what it's really concealing is that it's the relative speed of light between the observer and the source. So and that speed fluctuates relative to how fast the observer is going, right? So and that just as it would in sonar, right? For like in water, right? So like the water would be everything would be relative to your speed of the water, and like it's like literally the same mechanism. So like the fact that light does that inherently, that's just hands down. There's another medium facilitating that. Otherwise, it would be as Einstein says, and there would be no variance in it. And how do we know there's a variance in it? Well, check this out. When they transform the distance derived from the ECI reference frame to the ECEF reference frame, the one that they say we live on, it's a non-invariant transformation, and it absolutely has to be because it's time synchronized to the same time, and it's based on the speed of light, which they say is fixed. So there can't be any variance plus or minus in that regard. So the way that they try to explain it away is through they call it Sagnet corrections, and what they say is that the Earth is rotating, and like it's basically like you're rotating in and out of the propagation. So like the distance is kind of changing a little bit is kind of what they're saying. But when you get into the Sagnac effect and ether rotation and all that, you're going to run into real problems because Earth's orbital velocity is absolutely mandatory if the Earth is rotating, in space and all that, and then that's not present at all. Further in GPS, if you follow Galilean velocity addition, right? So like the way that you would normally do velocity, the Earth will occasionally be rotating into that into its orbit, so that those two speeds would be combined. So as I was saying earlier, how there's a variance in the speed. If they're going to try and attribute the Earth's rotating under it, uh, adding to the observer's speed, right? If they're going to try and add that in that regard, well, when the Earth lines up with its orbit, that would also have to be, that would also, like, it would show up in that as well. It would be like, oh hey, there's a 30-kilometer variance, 30 kilometer a second variance here as well, plus this guy traveling at 30 miles an hour or whatever, but that's not present. So that's another GG proof that the Earth isn't moving. And I kind of been
Hold on.
talking.
So let me slow this down for everybody.
Yeah,
Alan, 'cause there's a lot
go
to
ahead.
unpack
Yeah, go ahead.
here,
We
right?
went over a lot.
So,
Absolutely.
so first of all, what the main part of this, guys, is that they say that light has a speed, and that speed of light is constant. Okay, so that's like one of the postulates from special relativity and Einstein.
Yep. Second postulate.
So, okay, cool. So if we find a variance, which means a differential in the speed of light, that becomes a problem for relativity, which is used to explain a lot of the things in our observable reality according to science. So that's the first part of this. So from what I understand, is basically anything that emits a signal or a frequency, it can't surpass this constant speed of light. Am I right so far, Alan?
Yes, sir.
All right. So that means anything like GPS signals, any type of frequencies, lights, all of it has to fall within the speed limit of the speed of light. Now, when it comes to like ECI and ECEF, and there's a lot of gems that I picked up from Alan. So ECI is Earth-centered inertial. So inertial frame means unchanging, right? So either something's constantly moving at a constant rate, or it's just still. So when they're saying that they're building the GPS framework off of an inertial frame, Earth-centered, just like Alan said, this is basically they're assuming that the signal is going or coming from the center of Earth, so the rotation doesn't matter. So they're presupposing the sphere and that there's a center of it, although that also just aligns with just being on a stationary Earth. Okay, so peep game. So they're saying, I know it seems like we're stationary, but we're going to build the framework of GPS off of the center of mass where you won't experience any rotation. Then, just like Alan said, which we're going to get into, it's about the corrections. See, I'm tired of these globe earthers always saying, give me a flat earth map, Sacred. Give me a flat earth model, Sacred. First of all, y'all don't even have a globe earth model without corrections. Y'all own framework is built off of corrections. So if you can't provide me anything without corrections, why the hell you trying to hold me to a whole new standard? You the one that been spending trillions of my tax dollars on all of this science. Don't hold me to a higher standard, Mr. Globe Earther, sir.
Heavy on trillions.
Right? So they make these corrections, and they use these transformation equations to then move this framework from the center of mass, where everything is pretty much still relative to my position, to the surface of the Earth, and now we're rotating. Now we have problems with GPS because now we're including a rotating of, I guess, frame of reference. Now we need corrections. And this goes into the Earth-centered, Earth-fixed framework. So I forgot the name of the guy that you were talking about, Alan, that had the whole paper on this. That was a dope live that you did. Was it Wang?
Yep. Yeah, Ruyong Wang.
Yeah, okay. See, I'm getting my downloads too. You feel me? That's what I love about
dude, you're killing it, bro.
Hey, bro, I'm telling you, man, you inspired. I told you, bro.
You've been studying, dude. I can tell.
Hell yeah, bro. Bro, listen, let me tell you, and I don't know, like, I mean, he said this already, but for y'all who don't know, and I talk about this all the time, I was a college dropout. I had a scholarship to college, but I didn't finish, right? My man Alan right here, bro, I don't know if you want to tell him that your level of highest degree of education.
Yeah, bro. So I dropped out and got my GED, so I could, just be done with school when I turned 18, because I didn't. I think I needed like one more year to do credits or whatever to graduate. But I was like, miss me with that, dog. So I just pieced out with a GED, and I took like 2 semesters of DeVry, dude. You know, like literally just nothing. So
Shout
like,
out to the bride.
shout out to DeVry, dude. Definitely won't get employed or whatever. Shout out to the lawsuit or whatever. I just got an email from. Apparently, I get a settlement because they lied to recruit me or whatever.
Hey, things come full circle. You see how that works? I like it.
Yeah, absolutely. So yeah, dude, your boy's got no formal education or anything like that. I just started reading this stuff and like figuring it out, you know, as a hobby basically. Because I would watch Witsit dance on people in debates, and they would go, "Witsit's word salad, word salad." And I'm like, "Is it word salad? Let's take the Pepsi challenge and start learning new words." And like it turns out, guys, like the reason it sounds like word salad is because they use an entirely different language to communicate, and a lot of stuff is like, you know, highly technical and very precise. So they write it in like, you know, basically a foreign language that only makes sense to them. Very similar to, I'm sure a lot of you are familiar with Black's Law Dictionary and how and legalese, right? So when you walk into a courtroom, you're not speaking English, you're speaking legalese. Everything has a different definition that's bound to a dictionary that the normal people don't know about, right? So it's like a very similar.
Wait, you mean they're changing definitions? Now,
Yeah.
where have we seen that before?
Yeah, dude, exactly. That's how you know everything's on the up and up, when everything's exactly as you think it is, and you don't have to learn an entirely new language to decipher it. But yeah, that's why it sounds so crazy. And then like, you know, but once you learn the lingo, man, a lot of it starts making sense because you're like, oh, okay, this is what they're talking about. They're talking about right angles to this or that, you know. And you're like, oh, okay, I see what they're doing. So, you know,
And I wonder if they do that purposely, bro. Like, I wonder if they like use. I know a lot of these papers come from like international, I guess, sources, right? Where you got to translate a lot of these things. Like, you know, we got to translate Einstein from German. We got to translate Newton from, what was his? It was it Spanish or Italian? Something like that. We had to translate Newton as well. So I don't know if it's just like a language thing, or if they're literally just trying to make it so obscure that it just seems too difficult for people to like take the time out and, you know, read some of these things. But when I heard that, bro, and I heard your story about like how you started getting into all of that, it just reminded me of myself. And it's like, bro, I just had like, you know, the energy in me to just kind of take the extra step and the extra time to look at some of these details. And then it opens up a whole new reality, bro. Like, it's just so crazy. So when I tell you guys that don't let people, when they come in here with their credentials, talk down on you because you don't got this or you don't got that doctorate or this label or whatever, you don't need it. None of that, bro. Literally, just take the time out and literally just go through it step by step. Have the conversations with people, and then you can find out really what these high, quote unquote, high level sciences are really talking about. It ain't really that difficult. They just make it difficult because it comes from a fallacious foundation. So the calculations get more distorted, more intricate, because they got to keep on building on the misinterpretation of some of these things that we're talking about. That's why I want to get into a lot of these instruments that they're using, and implementing all of these corrections to get a value that they're looking for. It's like predetermined, bro. It's like, as I'm listening to Alan break this stuff down, I'm like, bro, we talk about this all the time, but it can't be that blatant. You can't take the things to debunk the globe and call it positive evidence. At this point, we got to draw some line here, guys. You know what I'm saying? This is crazy.
Absolutely, dude. That's why I titled my presentation on interferometry. Like, all the interferometry now belongs to us. If you guys want glob or you know, heliocentric measurements, you know, go measure the Earth's orbital velocity. We'll take all the sidereal rotations and stuff that you didn't want and act like they don't exist and transform it into, you know, a velocity that doesn't exist. Like, we'll take all that back with no corrections, and you can, you know, start your own interferometry and get your own measurements, guys. Respectfully.
So think about what Alan just said. What science is potentially doing is picking up this motion, right? Where you don't need any corrections to detect it or measure it or calculate it. But then they come from a framework of, oh, we're on a spinning ball. So this got to be the spin of the Earth. And now we need to correct for this, because now when we're implementing this framework, everything begins to fall apart. And it's like, wait, what? So this is why I wanted to talk about interferometry, because the way that they interpreted all these like direct observations. And we talk about the scientific method and a lot of these physicists and a lot of the experiments that they performed. Bro, just like Alan said, they have no detection of motion around the sun. First of all, they have a misinterpretation of the rotation of the Earth. It could just be the ether wind, which we're going to get into. Then they try to detect the motion around the sun. Failed. Then they say, okay, well, we're detecting something. So let's see if it's us moving or the sky, because that's what sidereal rotation is, y'all. For y'all who don't know, sidereal rotation is the rotation of the sky. So when you look up, you see the sky moving. We see the same sky every night. Y'all know how it go. We talk about this all the time. So they're picking up what Alan is calling this sidereal rotation, the motion and the movement and the circulation of the sky. And they said, well, how do we know, if it's us moving or the sky moving? So then they had to go into Aries failure. And I don't know if Alan want to try to break this down for us. But it seemed like essentially they used like a telescope, and they were trying to have light from the stars come in at a specific angle. And if they had to adjust it, it meant that one frame of reference was moving, which would be the Earth. And if they didn't have to adjust it or something like that, it was the sky that was moving. I think I said that correct, but if I didn't, help me out there, Alan.
Yeah, you nailed it. So let me make sure I'm unmuted. Yep. Okay, yeah, so that's basically it. So if the Earth were moving, they would have had to correct it by way more. And if it's not, then they wouldn't have to, right? So they came up with this story for Aries failure. If you read the paper, there's this. It's all about this guy's stationary ether theory. This guy named Kirkelfunkel or something like that, or Kirkelbacher. One of those weird names. But anyway, old Kirkel, his they make it about falsifying his stationary ether theory. But the other implication is a stationary Earth with respect to an ether wind that would facilitate that slight variance that they measured, but not enough to warrant Earth's motion. So it's literally just like a misdirect kind of thing. So there's actually, and people will say, oh, it's a failure because it failed to detect the ether, and it really somehow proves the globe somehow, even though they didn't have to make any corrections. So like that's obviously retarded. So there's a paper by Wilhelm Wynne from 1898 that Einstein references, and actually this was like a big influence on him because in this paper there's a list of 10 experiments that are listed that failed to provide Earth's orbital velocity, and Aries failure is on that list as a failed experiment for the Earth's orbital velocity. So it was understood then at the time, like in the time, right? Like in the context of the people that were writing about it and doing it and like lived through it, right? Like all these people were like, oh yeah, failed to detect the Earth's motion. Got it. Like we're all on board. But like nowadays it's told to us through the relativistic paradigm and like lost history and everyone's interpretation of the correctness of Copernicus's theories or whatever. So they're just like, oh yeah, it failed to detect the ether, and the failure part definitely means that it proved the globe somehow. So absolutely not true. Like there's tons of references I can find to support that, and I named one already. So
yeah, and these guys, they test this stuff like hundreds and hundreds of times. I mean, even just like back in the day, they was testing, these different motions hundreds of times trying to get a different result and could never get it outside of the observation. And just had to literally blatantly misinterpret everything.
Yep. Yeah, they literally had to when you read all these guys' theories and stuff about the ether framework, it's always stationary ether because they need the Earth to be moving through it to explain why they can't detect it properly, right? Like there has to be some reason why the translation of motion isn't properly facilitated, even though it shows up with a first order dependence in linear interferometry and circular. So
if it's a stationary ether, that means that it would be something local and it would have to move with the Earth then, right?
Yeah,
in the globe paradigm.
Yeah, so there's different iterations that they'll take for it, but yeah, essentially that's the one. It would have to be like an entrained ether for them that rotates with it. That's like separate from the galactic ether or whatever, that's like the quote unquote real ether that the Earth's traveling through, or its orbital velocity is moving through, right?
So basically, guys, with Michelson-Morley, they try to detect the motion of the Earth through the ether, and I guess based off what we just talking about, they had like three ways that they could have interpreted the observations, right? and they use a linear form of motion measurement. Although they do say the globe Earth is on an ecliptic path or elliptic path, excuse me, which is curved for this experiment, I guess, because of its locality. They were able to, just use it in a linear fashion. But they either had to get rid of the ether so that the Earth can move, keep the ether and make the Earth stationary, or they could keep a stationary ether that's local, that's not all the way out into the cosmos, and that stationary ether can move with the globe Earth. So they had three different ways to interpret the data, and guess what they went with? They got rid of the ether and went with a moving Earth through a vacuum of space. So then they, again, like I said, they went to Michelson-Gale, or Michelson went over, and did a second experiment with Michelson-Gale to try to determine the rotation. So they failed with the orbital velocity. Then they tried with the rotation. Got that totally messed up. And then we went into Aries failure. And then I think it was the Sagnac effect. It's kind of like the interpretation of light moving at different speeds, from what I understand. So these like four different parts, of this entire scientific, I guess, segment of history totally changed all of physics, which is why we're here today. So that's kind of what I wanted to like dive into. I do see Libra got his hand up. Libra, you want to jump in here? And if you guys want to come request the mic and talk to Alan and ask him questions about some of the things we're talking about, probably gonna touch on a few different topics, but I can't wait to hear from you. But what up, Libra?
Well, I just had a quick question about because whenever someone talks about quantum in spaces, I say that's because they just don't want to say the ether. And I first heard about the atomic theory of matter being fraud from Sacred, and so I like hearing Witch to talk about it. What do you guys? I mean, if you want to touch on that later or whenever, I'm really curious as to what you guys have to say about that. That's like my mind's still blown. Yeah, the atoms and the electrons, and I mean, I'm still like, how did they like I was arguing about electrons. I started saying, "Show me one," and then they acted like I was talking about electricity. We know electricity exists, but I suppose what the Whitson says about the clouds of probability. Based on this and reifications and presuppositions and blah blah blah, we might find an electron here. He was really funny about it. But if you could, what do you have to say about that later or whatever? It's just
don't forget about the heavier, overweight cousin, the muons. We can get into that too.
And the boson and oh my god, it's just yikes.
So science got to particleize everything, right? Because everything has to be materialistic. They have to quantify everything. They don't acknowledge anything that's immaterial. And I like Alan's description of like how the ether is formed. I heard him talk about how it's a toroid, and it has these different motions, which then can be perceived as Coriolis when you have like this inner and outward motion, clockwise and counterclockwise. I don't know if Alan want to jump into that, but on that scale, it could be a toroid or a toroidal field, and on a smaller scale, they could be what they call events. I heard Witchet talk about this, where it could be more like a toroidal field or some type of a fluctuation of a frequency, as opposed to particles. Because we heard of the physicist that came through last week. He told us that they don't have no shape, they don't have no size. They said these particles and subatomic particles don't even have a surface, but they have a radius though. How do you have a radius without a surface, bro?
Yeah, the old surface radii invisibility cloak. Who knows? Probably hiding in a math equation somewhere.
Makes sense.
Yeah, that's crazy.
Yeah. So,
dude,
like,
imagine telling someone with a straight face, like, nah, dude, it has no dimensions, bro. What's it look like? You can't see it. What? What's it do? It's spinning. How fast? We don't know. We can't see it. It's like, what? Yeah, that's awesome, man, that they're able to do that with a straight face. That's really cool.
Not only with a straight face, they'll get upset if we present a different idea.
Yeah.
Well, we talk to them about, we're like, bro, you gotta like detach from the emotions, bro, like, because this is supposed to be a conversation devoid of emotion, because that's what science is: removing your bias, removing your emotion, and having a somewhat of a intellectual, civil conversation, about what we're interpreting. And if we're not having that type of discourse, then it's just one hive mind, and we're never really going to progress if we just all are yes men with each other. So we see that a lot, unfortunately.
Yeah.
Go ahead, Libra. Libra got your hand up, bro. Hey, while Libra figure out why he's stuck in the ether, hey, y'all go check out my pinned tweet. Dope back and forth with Alan and Shane doing some reviews. Hey, that was crazy, bro. So I guess ever since Alan been putting out some of this content, right, he must have triggered some algorithm, because there was one clip that he put out where it was like the I don't know, the top of the pyramid was putting out like these viral videos seemingly directly responding to Alan's videos of what he was talking about in regards to ether wind and ferrometry, the speed of light. Bro, that was so crazy. It's like point by point,
Like
he was
a
literally going
pre-program
through.
rebuttal. Wow.
No,
Oh, dude.
seriously, bro. It was crazy when Alan was pointing that out, because I seen the video that he was talking about, and the response was literally like he was just addressing him one by one. And this is just some big random account or something like that. But bro, tell us about that. That was wild. I was dying laughing.
So I cut a lot of my initial reaction out of that, because it was just like me freaking out a little bit, going, oh my God, I can't believe how synchronicity, what a synchronicity this is, because it was just like you were saying, it was so on point. It was as if the guy, obviously he didn't watch the Globebusters episode, but it was like, so check this out. On like Sunday, I had did a Globebusters episode where I did a presentation on interferometry and GPS and just laid out the whole situation, how all electromagnetic propagation is, based on the ether, and, it's all like GPS is ether technology. It's all, hiding that. And then like literally on Wednesday, PBS Spacetime put out a special that was like going over point for point almost like my presentation, like kind of, and like refuting it, but like not actually refuting it, but just like saying stuff like, that's how we know the speed of light could never be changed, because everything would be wrong and we're not wrong. Like, like stuff like just like backwards circular arguments like that. But it was so crazy because it was like hyper specific to what I was talking about, and it was within 3 days, man. It was insane. So like, part of me is like, yeah, dude, a bunch of boys got together, wrote a script, and had your boy pump it out. And yeah, it was crazy. And then even the shirt he was wearing, did you see the shirts? It was like, don't talk about this, the devs will notice, or whatever. Like, all right, dude, I got you.
Subliminals, bro. And if you go back and look at that video, the dude doesn't blink. I don't know if y'all noticed that, but he don't blink. Yeah. I was watching. I'm like, bro, this was super weird, man.
Dude, is that what it was? I was getting weird vibes from him, but I'm playing it back in my head. He didn't blink, did he? Yeah, that's so weird. Yeah, dude, they MK Ultra'd him to bring that script in real quick to answer that, dude, because people were searching it. It was crazy.
And then you should see like Alan going through the comments saying like, too bad that C's variant. It's just like responding to all the comments. In the comments, I was crying laughing, bro. That was dope stuff, bro. Peter, what's up, man? Glad to see you back. Hey, man, I see you being a little bit toxic on the timeline, Peter. Chill out, bro.
Hey, Sacred. Hey, everybody. Not here. Don't worry about that. I'm here for different reasons.
Okay. Yeah. Just checking.
Nah, all respectful here.
Appreciate you pulling up. What do you think so far about some of the stuff we've been talking about? I know you got a little bit of some of the gems dropped last week. I don't know if you looked into a lot of the, because we were kind of like all over the place. I was just like super excited to have Alan on, and we were just kind of like touching on so many different things. But I did feel like I had to like come back, kind of do like a revisit of some of like the core points that we were trying to make, just so we weren't like so much all over the place. Although that was a dope stream. I think Alan was kicking it with us for like 4 hours straight. But I wanted to like hone in on some of like the details, so it don't like go over. Everybody had like anti-gravity because I know it's like a lot of information that we go over. But what do you think about some of the conversation last week and what we've been talking about so far?
Good stuff. Good stuff. I'm more interested in more fundamental questions before we get to the speed of light or quantum mechanics. I only have 2 questions about how day and night and seasons work on Earth. Alan promised to send me some models for that. I know this guy called Rufus. He shared with me a video. I asked 2 follow-up questions. He promised to deliver some answers shortly, but haven't heard back. So I'm more of a humble scientist here today. I'm just asking, how does day and night work and seasons? So, one step at a time.
Yeah, okay. So if you pull up a Gleason's map real quick, if you look at the bottom left corner and the bottom right corner, you'll see 2 distributions of light, one for the summer, one for the winter, relative to the sun's position in the northern and southern hemispheres, hemisphere, you're using that word a little loosely for your benefit, respectively. So that would be what the light distribution would look like, and the sun just goes over in a circle, right? Like did I not send you the ADL video where we go over the model and all that?
No.
Oh,
I tagged you a few times.
Oh,
but I'll
1 second, I got you.
No. I'll one up you on that one.
Yeah, go ahead.
Because Rufus gave me a video of exactly what you're showing. That wasn't new to me. There are basically 2 circles, right? One for our summer and one for our winter. I'm not going to use the hemisphere trigger word. Okay. And so I just asked the question because he said both are 6 months equal, right? Fair enough. Well, that means that the radial angular speed is the same in both circles. Therefore, the velocity of the sun must be much greater in the outer circle than it is in the short one.
Indubitably.
Yeah. He said there are observations being made, which would be groundbreaking and shattering to the globe model, since we, the mainstream guys, we claim that the sun moves with a roughly constant speed through the sky. But so he promised me those. And the second question that I asked was, how come on that map that you're referencing, the light kind of terminates abruptly when it's going north towards the center, let's just say towards the center, while it spreads very generously towards the ice wall or whatever the outer ring is called? So I asked him these 2 questions. What about this velocity of the sun changing so dramatically between summer and winter? Is that observable? And 2, what's the mechanism behind the awkward or unusual, let's just say, propagation of light rays from said sun, since it has a very odd shape? So what mechanism
I got you,
is responsible? Yeah.
I got you. Yeah, so the first question, not only is it detectable, it's measurable. That's what Dayton Miller measured. The speed fluctuations of the sun as it travels in the northern and southern hemispheres respectively. So you know how the analemma is bigger, in the southern hemisphere, right? Because obviously on a plane, as you get to the southern hemisphere, there's going to be a greater distance. So the sun's obviously moving, a greater distance. And to keep up with that speed, it's, linear speed has to increase. And that's what Miller is measuring, right? So that fluctuation speed as the sun comes in and out was measured to the day on the equinoxes. And then
what's the predicted, what's the predicted value? Because we know the radii of those circles, right? Certainly we can read them from the map. And we know the time to travel a full circle, that's, whatever a day is. And then, so what's the speed? What are the values?
Yeah, so in Gleason's book, he clocked the sun, the guy that made the map.
Alan?
Yeah, oops. Sorry, I have my mic muted. Yeah, so the speed, the linear speed, Gleason clocked it at between 900 and 1,300 miles an hour as it's going in the northern and southern hemispheres.
What are the calculated, not observed, I'm saying calculated speeds from the model?
You would have to refer to Gleason's book on that for the calculations, but that's what he got out of it. That's what he assumes that it's at. And if you look at the interferometry measurements, that correspond to the fluctuations with the movement of the sun, like the speed they get, it's not anywhere close to 30 kilometers a second. So they're like literally measuring a local phenomenon,
I don't think you got my question.
Okay.
If I know the radius of a circle, and I know the time needed to do a full circle, which is 24 hours, then I automatically calculate the velocity, correct?
Relative to your position.
No, relative to the freaking circle.
On what circle? The inner circle, the equator, the outer circle?
Both.
Are you
There
gonna
will
get
be different speeds, right? Because the circumference is different. The time taken is exactly the same, 24 hours, unless we claim that Australians experience a day that's not 24 hours. But I don't know if you guys got there already.
No, I just told you the sun moves faster. It's literally measured
By
in interferometry. I don't know. You
I'm
figure
not
it out,
asking
bro.
about the measure. I don't even know the radius because it's not on the map. So I'm not going to guess the radius. I'm asking, I specifically asked No Curve Rufus guy, what is the radius for each of the circles? Then I can put this in the calculator and I'll know the speed.
Bro,
and then we will compare the speed against the observation.
Bro, you're having like two separate conversations. I have no idea who Rufus is or what he showed you. I'm talking to you about interferometry in Gleason's map and what he measured the sun speed to be. So like,
fair enough.
So the answer to your question is that whatever Rufus showed you, I have no idea, bro.
So we don't, Sacred, we don't follow the method of like Xavier, you're a master of this. Like first we have a hypothesis, meaning we say the radius is X, the time is 24 hours, therefore the speed will be Y. We don't go down the route, we just observe and then we document and we claim a win.
So this is interesting conversation. First of all, I do want to say that Ken had, my man Ken down there had an interesting way on potentially determining the true radius on a flat plane. If you feel like speaking to come up, you can kind of talk about that. If not, it's cool. But one thing I do want to kind of like highlight is, you know, this change in velocity or this apparent velocity of the sun. One way that I kind of position it is almost like how you visualize a rainbow, right? Now, say you were standing in the front yard, you didn't move. There was a mist, right? And the sun moved across the sky. That rainbow is going to move relative to the sun, right? It's in an apparent position. So even if you're stationary, that rainbow is still going to move. You can never go to the other side of that rainbow either. So I think it might be something similar with the sun, where it could be some type of projection where like you have a source energy or a source light, and it could be projecting into our reality. So when you're on this plane, when you're closer to the center, it's moving at a certain velocity, even though it's the same rate, right? It's the same 15 degrees. And then when you move outwards, outer towards the quote unquote edges or the Antarctic circle where we can't cross, relative to our position, it's still moving at 15 degrees per hour, but because we're at a further point from the center, it seems to speed up that a bit. That's the apparent position. So that's kind of like how I like to think about it when you guys are hearing us have this conversation about different speeds. Just think about being in the center of a wheel versus the outer edge of a flat wheel. It's still all going to rotate at the same rate, but the inner part of that wheel is going to spin a lot slower than the outer part of that the wheel. Same thing if I have a flashlight in my hand. If I'm spinning in one spot, the flashlight in my hand isn't really moving that fast. But when I'm projecting a light onto the wall, that light has to keep up with the source, which is the flashlight. So the light is actually moving faster as I'm spinning because it has to keep up with the origin. So just to slow down for everybody so you can keep up with what we're talking about. Hopefully I made that a little bit more clear. Peter, do you want to continue with your question? There was something else.
Yeah, so that was a great explanation, Sacred. It's like being on a carousel or whatever the word is for that. So yeah, that's well understood. 24 hours, two different circles, therefore different velocity for each circle. I assume that we know the radii of the two circles because they are shown on the map at a very specific point, right? Therefore, we can calculate the predicted speed. That's how we do science, right? For the scientific method, we make a prediction. Then we compare it against observation, and there are two possibilities. Either observation matches those numbers relatively closely, or it doesn't. If it doesn't, then maybe that's what you hinted at, Sacred, but I'm not too sure. I heard other people say, maybe we now add to the hypothesis another possibility that somehow magically the light spreads differently because of its nature. Now we have to explain that. And maybe we also can use that uh, phenomenon to explain why the light has this really awkward shape, where it's kind of a half a circle and then like a flat top to kind of match, how we see night and day on the real Earth. So like we have to explain all those things in the hypothesis for it to even be considered. And I suggest, we should maybe start with that before we get into quantum mechanics and the nature of the electron.
Hey, I
Yeah.
mean, that's important though. Oh, go
Yeah.
ahead, Alan.
Yeah, no worries, dog. So Dave, or what's his name? Dave Weiss has a ton of videos on that, on the like light distribution through a what's it called, through a dome. So if you want to see like what a representation would look like on a quote unquote model, right, of like a domed curve, and what the distribution of light would look like from an outside source projecting in, it matches. Dave Weiss has reproduced light distributions that look like what how Gleason says it would work on a flat Earth with a dome, right? And Gleason was a flat earther as well. Right, and he had the only reason.
Yeah, thanks.
Yeah. So there's a possible mechanism there for that. It's definitely
Right.
definitely possible.
So,
and if you've seen that, then like, what do you?
I'm sorry. Yeah,
my dude.
No. I've seen all this, and these are like conceptual diagrams.
Sweet.
Hello.
Yeah, go ahead. Sorry.
The reason why I even say these things is because you make very, very advanced, very deep insights into very complex physical phenomena. And I'm asking you a very simple question. Giving those conceptual diagrams from David Weiss and other people, what is the actual science or your view of the science behind them? What are the actual numbers? What are the actual phenomena at play? Do you know this, or did you just skip immediately to quantum mechanics and ridiculing Einstein, and you skipped over day, night, and seasonal cycles?
So much.
That's what I'm asking you.
All that microaggression. Come on,
can I
It's
quickly
not micro.
interject? Because you're clearly missing the point, because you're talking about let's doing science, let's do an hypothesis and then confirm with observation. The scientific method is solely related to cause and effect. All that nonsense you just said has no relation to science. That was it.
Yeah, and we had a space on observational studies versus experimentation, be the scientific method, and what's most important. Which one's going to get the best accurate or the most accurate results, and adopting that experimentation is necessary within a scientific method. What are the implications for that versus observational studies verifying quote unquote science, things that you can't control, because there's a lot of different parts of science that they cannot control the variables and they still call it scientific. So that is a big part of the conversation. I do want to let go ahead, Alan, and after that we start over to Mars.
Yeah, absolutely. So last week I asked you if you knew about scale invariance, and you said to me, "Yeah, absolutely." And then you proceeded to ask me for specific numbers in regards to the size, distance, and all that to the sun, as if the scale invariance like had no implication or meaning or whatever. So the conversation has evolved past what's going on with the sun, because you guys can't even acknowledge, and by you guys, I'm not speaking for you. You might not be one of these people, but most globe earthers don't even acknowledge that a sunset could be possible on a flat Earth with perspective. They completely ignore that. They act like if you're in water, like on a boat, and you're looking at a bridge at the distance. They act like the bridge compressing to the ground, looking like it's touching the water. They somehow think that the bridge is touching the water. Like that's what has to happen for the sun to disappear in the sky, according to them. So that must be what has to happen for a bridge to disappear. But that's not what has to happen. It's very, very cut and dry logical conclusion you could deduce from that to figure out if something is actually if something is in the sky, and if it's actually being obscured by the physicality of the curvature of the Earth, right? So just in terms of that, like getting over that hurdle has been a complete waste of what's it been, 10 years or whatever. So that's over with now, dog. So we're going on into the mainstream interpretations of the underlying issues of how you guys come to think you're still on a ball when it's not even possible at all. It's like, it's cool that you got model questions and all that for me. That's dope, dude. But like, I don't have those kind of answers for you. And if that's like your point of a quote unquote attack to like challenge me or whatever, like that's cool, man. I got nothing for you other than the sun's speed fluctuation changes have been moved, and the translational speed was clocked by Gleason's at 900 to 1300 miles an hour. So like if you want to talk about radiuses and circles and assumed orbits and distances and all that shit, like, that sounds like something you could do on your own time.
Well,
Can I just respond or?
I'd
Yeah,
prefer,
and while you do, Peter, just let us know how you think it should work, how you think sunsets and things like that should work on a flat Earth. Let us know how you believe that. So go ahead.
Yeah. So for all of you listening, if you've heard me speak before, I never debate for or against the globe. That's not my tactic at all. All I'm simply asking, I'm ignoring the globe. I'm asking, what is your hypothesis and prediction for how the sun operates in relation to the Earth and how it causes day, night, and seasonal cycles? Okay? And I am asking only one question, Alan, or whoever volunteers to give this information. What is the radius of the summer and winter circles? Everything else I'll do myself. I just want you to give me that number based on the map that you favor, because all I have is TikTok videos with slightly different maps. Not going to fall for the trap of trying to measure the distance on those TikTok videos. You just tell me how many thousands of kilometers or miles each of the circles is on your own map,
How
not
should we
on mine.
determine that? How should we determine
I
that?
don't know. How did you determine them when making the TikTok video? It has them in very specific places on Earth, right?
Hold on.
Rufus,
How do we
you know what I'm
determine
saying.
what about TikTok?
Whoever makes those videos, David Wise or whoever, has circles placed over the Gleason map in very specific places geographically. So someone put those circles on in those videos, right? So they know what the radius of those circles is in reality. Can I just ask for someone to give me those two numbers, and I will make calculations in 10 minutes, and I'll draw my own conclusions. Then I will look at the observations that Alan is referencing, and I will compare them. Is that a fair question to ask, or am I being microaggressive right now?
So it is a fair question, but I don't think that it's something that we can answer right now, right? Because again, that's why I asked for the methodology and how would you determine these radiuses or these circumferences or whatever you're asking for.
I cannot, because I'm not the person proposing the hypotheses. I'm here openly minded asking.
I might have those numbers for you. I can look them up. I know I have them somewhere. There's also multiple
Thank you.
times
Can you please
where
post them?
Yeah, I will get them for you.
Thanks.
Where different people did the same observation from perpetual rays, did the calculations on it, and each and every time they came between 5,500 and 6,000 kilometers for the height of the moon and the sun.
That's not what I'm asking. Sorry, I don't want you to be looking for the. I'm asking about the radius of the circle.
It was brought up earlier that you asked it to somebody else. He explained it to you. That's why I'm giving you this information.
Okay. So just to clarify, for those of you who might do the work on my behalf, which I would be grateful for, I'm asking for the radius of the circle that the sun makes when it's summer, let's say North America, and the other circle during summer in Australia. As per the map that Alan's referencing, the Gleason map and the different models that I've seen, I'm asking those two radii. Thank you.
Isn't that the equivalent of when we asked for the radius of the Earth? The globe?
No, I'm not a glober. I don't care about the globe.
Peter, I think one of the things though is that why do you assume there's only
You rubber banding, bro. We can't hear you, Bradley.
It's been hanging out with those bots too much.
Malfunction.
So I got the numbers here that are assumed. So the Earth's full diameter, 50,000 kilometers. Earth's no ice zone diameter between 30,000 and 35,000 kilometers. That is the outer side. So let's say the ice wall. So Antarctica is probably between 30,000 and 35,000. The sun and moon's altitude between 5,500 and 6,000. And the sun's diameter and the moon's diameter are approximately 51 kilometers.
And none of these numbers are the numbers that I asked for.
Dude. Cry me a river. Oh my lord. I'm giving you the numbers as I find them. So could
but
you
that's
please
not
just be
for that's not for Alan. Do you understand what numbers I'm asking for the two?
Yes, I know exactly which
I got you,
numbers
homie. I don't
you're
have them,
asking.
though.
The circumference of Capricorn,
I'm asking
Cancer,
Alan.
and
Sorry.
the equator. I get it.
No, I'm asking Alan now.
Yeah, I got
Bro,
you, homie. I don't
he
have
said
them.
mad.
See,
he said mad
bro,
times he don't
ladies.
have it. You gonna take the ones that you getting, Peter, or you only
But
want?
they're
Alan's
for
numbers?
no, they're for the wrong thing. I'm not disputing the values of them. It's like if I asked you what's the weight of your car and you gave me the length of a aircraft carrier. Like that's not what I asked about, right?
Oh man.
I'm giving you numbers directly related to our supposed possibility of what it is. All directly related. And I'm coming to the rest of the numbers. So you saying that it's equatable to a car and an aircraft carrier is just stupid. But we all know you are, so don't worry about it.
Alan, do you understand what I'm? I think you do. I can tell that Alan understands what I'm asking.
I said yes already, and I don't have the numbers you are looking for, my good sir.
And that's a fair answer, but whoever is the other person speaking, I have no comment for that. I think you know why. Alan, right? You know why.
Alan, do you know?
What's up?
Hey, New Steak, what up, man? Big Colorado in the building. That's my clone,
I'm
y'all.
gonna do some other thought. I can't believe these people actually think of themselves as grown men. It's fucking hilarious. I wish you
You're
all.
hurting their ego, man. We're hurting their ego. That's where they're coming
It's
from.
insane, dude. It's not even funny. Even my 15-year-old is cramping in the back room. It's not even funny.
Oh no!
I'm not even joking.
Yeah,
A
that's insane.
15-year-old telling me in the back room that this man is acting like a child. Now that's fucking funny.
Isn't that crazy?
Well, that's the only reason we came. I came for the drama and the cringe. So keep it up.
You ain't come for no answers, bro. You don't have no questions on the ether wind, interferometry, some of the instrumentation, Michelson-Morley, Michelson-Gale, GPS signals, speed of light,
Frequency, vibrations, cymatics, all that stuff. I love it. I'm just here to hang out and listen.
What are you, a globe earther or a flat earther?
We're building a whole game based on waking people up to flat Earth.
No fucking way. What is it called?
Oh, that's dope.
It's New Sacred. We're a Web3 game.
I'm gonna follow you. Keep me posted on that, Twitter.
Oh yeah, we like to troll. We like to hop in the comments, and we like to fuck with people.
Great energy. I dig it. Hey, Bradley, what's up, man? Bring some of that globe energy in here.
Bradley be popping hella shit on the TL.
Oh no, Bradley, you be popping shit on the TL, Brad. Come on, Bradley.
Nice and calm and respectful now. Interesting.
What's up, bro? What you got for us?
I had a question for Peter, actually. I was wondering why Peter thinks that there's only two radiuses. Because actually, it's not like we have only winter and only summer. It's a gradual progression from one to the other. So it seems to me that the sun can't be circling around in, one path or another. It's got to be a gradual progression from one to another, kind of like a spiral going in and out, don't you think?
Look at you, level head ass. Okay. It's your coherent thought, face ass.
Yeah, big
Finally,
praises.
good question.
Who was that? Who was that asked the question?
Big Bradley in the building.
Oh, Bradley. Nice to meet you, Bradley. Yeah, I'm impressed. Yeah, I immediately realized that the two circles are the extremes, the solstices, right? The winter solstice and the summer solstice. So they're the extremes. And I want to first calculate the speed of the sun, linear velocity during those extremes. And of course, nobody told me that, but I figured out that the speed has to kind of speed up when it's going from the small circle after the day after the solstice. It's going to be slowly speeding up and traversing through the inner circles all the way to the other one. And then after the winter solstice, it's going to gradually start slowing down. So I understand that. But it's easiest to measure the speed at the extremes, compare versus observations, then we can do the more complicated math in between. We will, by the way, immediately know the acceleration of the sun as well, because it only has 6 months to build up its speed from the slowest in summer to the fastest in winter, right? So we'll know exactly what the acceleration is as well. Does that make sense? But you're absolutely right. It will need to accelerate when transitioning between those circles.
Hey,
Yeah,
speaking
I
of,
think,
oh, go ahead, Bradley.
yeah, no, I think my point was going to be that you're making life a little bit harder on yourself, because by looking only at the min circle and the max circle.
And that's what Dayton Miller measured, by the way. That's that constant fluctuation, right? That's what's building its minimum and maximum dimensions and the readings on the equinoxes to the day. Like, so as this guy was asking me earlier about the same exact question, and then just not, acknowledging that, very cool. But it's like that's what Miller measured. 5,200,000 times.
I agree.
I mean, globers do have their numbers, that we think are all fake and made up, but they do have numbers. So all I'm asking is for something like that we can at least use for a rough estimate calculation that we could then compare against the observation, because we're trying to validate the hypotheses. Like the sun moves the way it moves, regardless of what we think about it or what we believe. We're trying to validate our hypotheses, not tell the sun what to do. The sun already knows what to do.
The fuck is this guy talking about?
Hey, what's interesting is shout out to Jaren. I think he's doing some type of observation or an experiment in regards to measuring the amount of daylight relative to each side of the hemisplane or hemisphere, whatever perspective you adopt. Alan, do you got any info on that for us?
No info as of yet. I think it's still ongoing. We got a couple of guys in Australia and some guys in the north as well.
So what are they actually trying to figure out with that particular experiment? I think they're trying to see if the days last long like it's supposed to last, or short they're supposed to be.
Yeah, so the amount of time it takes for like the sun to actually disappear, like from twilight to darkness or whatever, something like that. I forget the specifics on it, but it's in regards to how they measure what is it, when twilight and stuff starts. I guess they do it by angles instead of luminosity or whatever. So they're tracking the luminosity to see if to get the actual difference, and like it to see if the sun is moving away faster, right? Essentially.
Right, because so if the Earth is pretty much an equilateral oblate spheroid, then during the winter, their days should be pretty much the same length as our winter days in the northern. Is that kind of how it is? And if it's something different, then that's a problem for the globe.
Yeah, it should be pretty much symmetrical.
So I'm interested to see how that turns out. Oh my God, Ken is up here. Let me bring him up here. And Liliana. Ken, what's up, my guy? I don't know if you can hear me. What's up, Ken?
Yeah, you hear me now?
Yeah, there you go, bro.
Yeah, I had myself on mute. So he's looking for like a radius, right?
Right, yeah, and I remember
Peter?
that you was, yeah, Peter was asking for one.
But I don't know if you guys can.
Oh, you kind of breaking up, Liliana. But go ahead, Ken. Yeah, so Peter was
so
asking for some distances, and I know you ran by some calculations by me a couple months ago. I don't know if you had any information that you wanted to share.
Yeah, so just it's the way I figure it. The only way we know to measure large distances, on Earth is through celestial navigation. And so we know that the equator is, 90 degrees from the center or the North Pole, whichever way you think of it. And then, those are all your latitude lines. So for every degree, we know it's 60 nautical miles. So your equator would be 5,400 nautical miles radius. These are all radius numbers. Now, your Tropic of Cancer, which is inside the circle, is at the roughly 23.5 degree latitude. So when you subtract that from 90, that's 66.5 degrees. That equals 3,990 nautical miles. And if using the equator is 90 and going to the Tropic of Capricorn, which would be 23.5 degrees or 6,810 nautical miles. Does that help? Those are all radius. Peter?
You lost me there because you seem to be using kind of globe speak here, if I may say so myself. North, south, degrees. I was thinking.
Oops.
I had to snap out of that. And whatever your predictions for radius on the.
There we go.
Closer now. Dance a little closer tonight.
Ugh. Shit. How do I unmute always?
Goes in circles that is local. So like, what's your best shot at what those radiuses are is what I'm asking. And if that's the numbers that Ken quoted, if you could post them on Twitter for me just in text form, I
Come
would
on,
appreciate
Peter.
that.
Now you asking for too much, bro. You
All
asked
right.
for the numbers.
Okay, no,
We gave you
I'm
the
sorry.
numbers.
I'm
You
sorry.
are capable
You're
enough
right.
to write
You're
this
right.
down.
You're
Bro.
right. I'm moving to my desk now. Just give me
This
one
guy.
second. 1 second. My
Right,
bad.
yeah, I know
My
you don't
bad.
like the horizontal linear pencils.
Yeah, no, I'm gonna use
happy to give them
digital.
to you again.
You know you don't like
Yeah.
flat
Tell me when you're
paper.
ready.
Once I got it. All right, you go. Tell me the smaller radius first for summer solstice.
Okay, for the Tropic of Cancer.
Dude, I can't wait till this guy comes back and like compares the numbers to the globe, and he's like, "Oh my god, it doesn't match" or whatever, and calls us retarded. It's gonna be great. It's definitely worth giving him numbers.
Tropic of Capricorn, it will be 6,810 nautical miles.
Okay, awesome. I can already tell the difference in speeds. And what was the equator, just since I have you here?
5,400.
Thank you. Nautical miles. Thank you.
Yeah.
Now, Peter, with those figures, what do you plan to derive from?
I will derive the linear velocity of the sun as we observe it during our summer, and as the Aussies or Kiwis, I think I see one Aussie in the audience here, maybe a Kiwi. I cannot see the colors of the stars on your flag, brother. So he will tell me, if he observes that fast-moving sun during his summer. So I got everything I needed. Thank you.
So, hey mate, I'm actually Australian. So, what is it that you want to know? And I'm on the east side of Sydney.
I'm gonna calculate how fast the sun should be moving through the sky for you during summer, which should be soon for you.
Yeah, it is summer for us now. Oh well, it's
Almost.
not summer, spring.
Yeah. So during summer solstice, when you come outside, you will see the sun moving through the sky much faster than, say, Ken and I do during our summer, and we will compare those observations.
You know, it's funny you mentioned that. There's two things that I notice. It's not just the speed, but for example, during our autumn, which is closer to your summer and closer to our winter, the sun sits lower because I know I've got a I've got an office on level 6 that faces the north. It faces the Harbour Bridge, and every single time the seasons change, the position of the sun also changes. I know we always have to put the blinds down. Okay, so and it kind of makes sense, right? Because when you think about it, our summer.
Let me see if this video from Shane has what I'm looking for. Oh shit. What was it? Is this? Yeah. The sun's speed in autumn equinoxes necessarily just 15 nautical miles. Yeah, 900 miles. Yeah, right here.
Starts to penetrate through our windows because it's now further away, and the glare starts coming through. But when it's our summer, put it this way, I use the Flat Earth app, and everything about it makes 100% sense, perfect sense. Everything is explainable. Even July, when the sun hits the kind of like moves closer into the center of the firmament, the mainstream media runs a headline that says 99% of the world's population is facing sunlight. And when you look at the Flat Earth app on that particular date, which is the 13th of July of every single year, it makes perfect sense. But every single time you ask someone that believes in the globe to explain that, they grab a flat map and then place the sun on there. I'm like, mate, that's not what I asked. Show me on a sphere how 99% of the world's population can receive sunlight. Like, you guys are insane. You can't grab our map, which doesn't look like our map, by the way. They've just kind of flattened it and go, oh yeah, look, we're just gonna place the sun here. This is how it works. I was like, that's not how it works, you idiot. Grab your globe, grab that one that brainwashed us in primary school, spin it, and then grab an object like the sun, and then show me where was it positioned that 99% of the world's population can get the sun. Because when we look at the Flat Earth app, it makes perfect sense.
So cool stuff. Like the phenomena you shared. I've never been to Australia, but I've lived in many places in the northern hemisphere, and of course, what you're observing is exactly what everyone else in Europe will observe. If you through the year, the angle of the sun is different, and if you live in Italy, you'll see the sun in a different place in the sky than when you live in Sweden. Okay, and I've lived in those places or nearby places, so I know what you mean. Nothing special about Australia there.
Nothing special about the down under?
No, nothing. So
down under what? There's no direction.
No one gives us credit the fact that we're able to urinate upside down. Do you know how hard it is for men to urinate sometimes
I know.
without splashing the sides. We've been urinating upside down, and no one even bats an eyelid. No one cares the struggles that we face every single day.
I know, and I've had my fair share of Fosters in my life, and I know how much urination is involved. So I'll tell you right now, the speed of the sun, linear velocity in European summer is 1,044 knots, nautical miles per hour. And in the southern hemisphere, or in Australia, would be 1,782, so 70% difference. So that should be quite noticeable. And by the way, mate, your days during the summer should be much shorter than ours. So I'm sorry that you drew the short straw, so to speak, because summer is when we have longer.
Funny about that, it is and it isn't. So the way that they've
Mhm.
adjusted that to make it look like our days are longer, is we've got something called daylight savings, and that
Oh.
that gets activated in October, the first week of October. So it gives us this illusion that we're having much longer days, but in actual fact, you might be right, but we don't feel that it's
Yeah,
quite the opposite.
Right. So if you were to count the hours, not looking at the clock, but like from from dawn till dusk, you should be getting like 70% fewer. Well, I haven't done the math yet, but noticeably fewer hours, no matter what the clock says in terms of what hour it is, than us Europeans. That sucks, right? Like your days would be like, 50% shorter than our days. That's horrible. I feel for you.
Let me go to my Weather Zone app, which is an Australian weather forecasting app, and I'll tell you. So our sunrise starts at here we go. Sorry, just 1 second. Oh, they've changed it around. I'll find that and I'll share it with you. I'll take
Thank
note.
you. And if you could also tell me what city you're in, so I can look up the longitude. Oh, Sydney. Okay. And I'll find a corresponding city in Europe that has the same opposite position on the supposed globe, obviously, and or per the Gleason map, and we will compare these two. All right.
Yeah,
So
no worries.
let me know.
My
Thank you.
DMs are open. You could message me anytime, and I'll respond.
Awesome. Thanks. I'll look up the daylight also on the internet for Sydney. That's unless it's fake data, you can never be sure these days. So you tell me your version as well.
No problem.
Can you guys hear me?
Yeah.
Yeah.
We got a couple hands.
I think we're done.
I was stuck in the ether. Just real quick before we get to the hands, Peter, why do you say that the days will be like super shorter?
Because the sun will go over your head much faster.
But if it's over a longer distance, wouldn't that balance out?
Well, we will see. We will make adjustments to the hypotheses, I guess, if it doesn't match observations. First, I'm
but I'm just saying,
prediction.
Just like if we're talking about perspective in the actual model itself, right? So these lines of longitude will diverge, which means that in the southern hemisphere plane, there will be a greater distance for the sun to travel.
Yeah, but it's going right over your head, right? If you're on the tropic, then it's going right over your head in summer, right? Like 90 degrees.
It's still traveling a greater distance though, because aren't those lines supposed to start converging after the equator?
Yeah, but per distance on land, like as you see it, it should cover that distance at a greater speed above your head than
but it's at the same rate. But it's at the same rate.
No,
if it's moving at
the angular speed.
If it's still moving at 15 degrees per hour, it's moving at the same rate along across a longer distance. It seemed like it would make more sense to have shorter days if it was a sphere, and then those lines of longitude converged. Then that would make sense for it to have shorter days because it's an equal hemisphere as the northern. But if it's traveling a longer distance and still moving at the same rate of 15 degrees per hour, how would we notice it moving faster?
Because it's doing many more miles per minute per hour
Nah,
than
dog.
in the other location.
Sure wouldn't.
So even though it's traveling a longer distance, you feel like we would still notice it moving faster?
Yeah, like the same way you gave this example with a carousel, right? Merry-go-round. If you're standing in the middle, you experience a slower speed because the distance covered by that part of the circle is way smaller than on the outside. That's why on the outside your head spins and on the inside doesn't spin as much, right?
Yeah,
I'm simplifying,
it
but
does.
you know what I mean.
Yeah, but it's moving at a longer distance. So I don't know if it would have shorter days. It would seem like it would balance, it would be directly proportional.
I know what you're saying. So basically, the overall Earth day will be the same, 24 hours, because it's going to do 360 around the circle. But when you're standing on the ground and the sun is above you, it's going at a faster speed than if you're standing in Europe, because it's really hauling ass to make that 360 in 24 hours. So it's hauling ass. You're going to see it. Same as an airplane that's flying over you, fast or slow. Like you see the difference. Right?
I don't know if that's the same. I don't know if that's the same correlation. I don't know if that's a good analogy.
Well, the prediction from the hypothesis is the sun goes faster in Australia to cover 360 of a large circle in 24 hours. That we agree on, right? And has to be the case.
Can I just chime in? I think I would have to agree with Crypto Keys. You know, one thing that does happen before daylight savings kicks in is we start to experience longer days of sunlight. So we're not like, it just kind of gets amplified when we turn on daylight savings. But leading up to the date that we're about to make the switch, we start to go, oh wow, look, the sun's like, we always know that spring is arriving soon, because all of a sudden, even before we change our clocks, the sunlight starts to appear a lot longer. And we're like normally, like in the dead of winter, we're lucky to get any sunlight after 5 o'clock. As it gets
I
closer,
understand, mate, but you're not getting my point. Like the change in the clock does not matter. What I've just calculated is that in Sydney, you're getting 14 hours and 24 minutes of daylight at solstice. Feel free to give me a different number. And it doesn't matter what the time on the clock is, like you're getting that many hours, right?
No, I guess the point I was making.
He's not talking about the clock, dude.
I'm saying even before we change the clock, all of a sudden we're like, oh, mad, spring is coming, because all of a sudden we're like, oh, it's 6 o'clock, mad, the sunlight's
Yeah, everybody sees that. Everybody sees that.
Okay.
Everywhere. So, yes.
Okay, we'll test it. We'll test it. I'm here in Sydney. I'm happy to provide you, like, real life data, like show you photos at certain times, or and where the sun's positioned. But I'll tell you without a doubt that the positioning of the sun definitely moves. When it moves further closer to the firmament, it then starts to become annoying for all my staff. We always have to put down all the window shades that blocks it out. So
yeah, I agree with you. I've never been to Australia, but I could tell you exactly the same experience from Europe or the United States.
And I'm on the 6th floor as well. So at the moment it gets up to autumn and gets closer to, it's mainly, I think, autumn that it happens. I know, because every autumn I'm like, oh God, here we go again. It actually, it creates this ugly glare in the throughout the windows. That no one can see the monitors. So I've got these shades that don't block out the sun completely. They just block out the glare.
No, I got you.
And it's never an issue in the middle of summer, by the way, when the sun's sitting higher above.
And just real quick, I just want to take this a quick opportunity before we get to the rest of the hands. Shout out to Shane St. Pierre, Anti-Disinfo League.
Hello.
Hold on one second, Gaji. Just give me 1 minute. I'll get to you in a minute. I just want to shout out Shane St. Pierre. Prayers be with him. Hopefully everything's good with him. But the celestial bodies and how things move in the sky, like that's his bag, bro. I remember reaching out to him in like I forgot what episode it was. It might have been like around episode 58. And we were talking about some of these motions of the orbital bodies, all the orbital is begging the question of gravity, but you guys know what I mean. But yeah, like this celestial observations and some of these motions, that's really his bag. And I wish he was here to speak, but hopefully he'll pull back up and within the coming weeks, and we can have those discussions. Because I really like how he articulates some of these things that we're experiencing. But let's slide over to Liliana. What's going on? Good to see you on Flat Earth Fridays, Liliana.
Can you guys hear me?
Yeah, you sound way better than last time.
Oh, goodness. Yeah, I think I have just a real connection. Sorry about that.
Yeah, it's kind of going in and out,
I
but we could.
don't know why.
Yeah, it's kind of choppy.
Yeah. Okay, just let me know if, because I'm near the window.
Can you guys hear?
Oh, I was gonna say that.
If she has any apps running in her background, that could be affecting her connection.
Dude, your girl is lagging to infinity. It's crazy.
Rubber banding.
Can you hear me?
No, your rubber band is so crazy, unfortunately.
Oh, sorry. Well, just let me know if you want me to talk or not, because if it's a bad connection, then I can just talk later. Or
Oh, now we can hear you good. Don't move from where you at.
Okay.
Stay right there next to that satellite.
Yeah. Okay, so I was just gonna say that, just I think regular globe science.
Come on, Elon, chill.
Dude, they took her out, man.
Gee whiz. I know you don't like space, but this is spaces. Let us do our thing. I mean, you saved me from NASA. Let us rock out every Friday. Gee whiz. All right, while we pull Liliana back up and she get connected to her geosynchronous geostationary satellite that needs special relativity to work, although not really. Let's go over to Gaji. Is it Gaji?
Yeah, hello, everybody.
Can you hear me now?
I have some question to you. Would someone...
Can you hear me now?
Yes,
Sorry.
it's not
Just 1
possible,
second.
please. Would someone explain to us exactly what is a light and how is spread on the earth and what is a longitudinal way? And second, if the earth is a flat and I stay in the darkness, I should see the sun, but I cannot see in. Why?
Ich habe dich verstehen.
Perspective.
I did, excuse me, English is not my favorite English. I repeat, when I stay...
No, please don't repeat. Please. Tune back in a second. I guess I should just turn it down.
Darkness, I cannot see a sun, just stars. Why?
Okay, so I think I see what you're asking. First of all, how do you say? Is it Gagi? Gaji? How do you say your name, bro?
Also Gagi as Aliba.
Gagi Aliba. I'm gonna just call you Big G. All right, Big G. No gravity. So we don't live in a vacuum along a smooth surface. So if we lived in a vacuum where there was no or atmosphere, if you still live on your ball, and we lived along a smooth surface with no topographical land masses, then I would probably see where you're coming from, being that we would then be able to see some of these luminaries far distances. But we don't live on a smooth surface. We have mountains, peaks, and valleys. We have light attenuation, where light doesn't quote unquote travel forever.
It's not
Certain
true. It's
certain
not
mediums,
true because
is gonna
the
block the
sun
light
is
from
so
penetrating
high.
higher
Sun
than.
is so
regardless.
high. And I must see if I stay in the darkness.
Yo, it's a local light. It's not
Homie just
93
assumed
million
how high
miles
it
away.
is, dog, and then said, "Nah, it
So it's
can't
like a
be."
small
How
local
So-
light.
spread the light?
So
How
crazy.
spread the light?
How spread? Like how
The
much?
light.
How much does it cover the land, are you saying?
The light have a straight so lines or not?
No, not parallel. I mean, not the way that I observe them. I observe diverging rays. They're
He
not
means that it
parallel.
spreads in a straight line. That's
I
what he
think
means.
he's. I think
Yeah,
he's
straight
asking.
line, straight
I
line.
think. I think he's asking why he can't see the sun when it's really far away,
Right.
as it's traveling away from him.
So yeah, I don't know how to translate light attenuation. I don't even know his language. But I mean, that's how it would work.
He speaks the language of Einstein.
We can't not see the sun because on that night he is on the other side on the earth. And that is plausible explanation.
Entschuldigung, mein Herr, sprechen Sie Deutsch vielleicht?
Ja, spreche ich Deutsch.
Danke, danke.
The Deutsch.
Hold on, what language y'all speak? I thought you was Polish, bro. You speaking German or something? What you doing?
I told you, the language of Einstein, right? Einstein war ein Deutsch.
And
Nicht wahr?
Can I just
what
tell
is longitudinal way?
Hey, Gaji, the sun's light only reaches half of the latitude. Latitude-wise, it only reaches half of the Earth, even on flat Earth. So it's the sun's light is shaped round, like think of a round, from like a spotlight, how a spotlight would be round.
Spherical distribution.
Light spreads so a geradlinig, or how is this of English? So would you help me, the German?
Yeah, genau.
The light only reaches, from just basically it'll be under the under the circle of Arctic Circle and way above the Antarctic Circle. So that's the length of the light beam, right? The light of the sun. And from east to west, it's only going to go for half of the latitude of the flat Earth. So, and it's round in shape. Did I make myself clear?
It's not exactly that is not true.
Yeah, because
would
the sun is
somebody
local.
explain what is longitudinal wave? Longitudinal wave.
What? Sorry, I didn't understand.
Longitudinal wave.
Longitudinal
wave, yeah.
Yeah, longitude-wise, it depends on the season, right? So in July, it's going to be higher, closer to the Arctic, because it's directly above the Tropic of Cancer. And then in December, it'll be above the Tropic.
No. Longitudinal. Wave is the sound in ether. You should read some exactly book from einen scientist who explained for 150 years ago. Longitudinal wave is the sound in ether.
Oh,
You know, maybe Peter could help us out here. Peter, you could calculate the distance for us. Take a point, say, in Florida or Texas, and then take a point someplace in India, which is on the other, which is 12 hours difference from us. India and Texas, I think, are 12 hours difference. And then calculate the distance to the sun from each of those points. And we should be able to tell if it's difference. You know?
I don't get it because the time zones don't matter. Time zones are just convenience things.
I'm saying if you take the sun at say 4 o'clock in the afternoon and measure the distance from Texas to the sun at 4 o'clock Texas time, and then the distance from India to the sun at the same time, whatever, 4 o'clock in the morning or whatever it is. I'd be interested to hear what those numbers are.
Well, they're tiny because I can only make the calculations based on what I know. So I am call me crazy, but I believe in the stated speed of light. And the Earth is so tiny that it takes a fraction of a second for light to get to any part of the Earth. The sun, I think, circles the whole globe, pardon the use of my word, globe, I think like 8 times in a second. So this is just funny, like we wouldn't notice. That's how fast it would be. But I'm not sure if that's the question, really.
Yeah, no. I'm saying if I understand the explanation. The reason that it's you can see the sun in Texas, but not in India at 4 o'clock in the afternoon is because the distance.
That's the part of I know your question. I get it, because that's one of the questions that I asked to Rufus, who's here somewhere. He looks like Ice-T. So Ice-T, he shared with me a video, and that video answers this question, and it answers it by showing a really weird shape. I think that's what the German gentleman is asking. Really awkward
what you know
shape.
about Ice-T, bro?
I used to listen to my favorite band used to be Body Count. Body Count in the house. Body Count in the house. So I know my Ice-T music, but I like him when he does metal more than rap. So
the fuck?
So Mr. Ice-T told me that that what's responsible for that, why Texas sees it and India does it, is this really awkward shape of light distribution. And I think the German gentleman is asking, why is this shape that way? Or at least that's what I'm asking Ice-T in the Twitter feeds. And I haven't gotten the answer yet. And that's the same question I asked to Alan. But that's my second question. The first one was about the speed of the circles themselves. So we'll worry about one thing at a time. First, we'll talk about the circles and the tropics and whether that matches observations. If it does, then we're going to worry about the distribution of the light, which Gagi asked. But if it doesn't match observations, then back to the drawing board. No point asking the second question if we cannot answer the first one. I have some numbers for you guys. You guys want to hear?
Yeah.
Because I've been doing good work here in Google Sheets. I would happily share these Google Sheets with y'all if I could post here, but it's blocked. Posting here on Twitter is blocked.
So for anybody that's here, all you have to do, I posted the space tweet all the way to the top right in the jumbo. So if you want to comment anything, since Elon hating on my purple pill, I don't get no chat box. You could just go to my my tweet on the top right, all the way to the right. It says interferometry is science presenting falsifications as positive evidence for scientific theory. You can comment under there anything that you want to share to the space, and we'll put it up top or talk about it.
Awesome. So how about I do this before I start speaking? I will share the spreadsheet with you all so you can open it and look at it. And then I'll walk you through it, and then you will call me out on any mistakes I may have made. Sounds good?
Don't open that spreadsheet.
I will link it. I
You
haven't
gonna hack
linked it
us,
yet.
Moody?
Hey,
Yeah, I think so. He's gonna get that data and try to manipulate it for his own little personal data set, aren't you? No, I'm just kidding.
hey, I don't know if you guys can hear me, but I had started to say something, and I don't know if you guys want to hear it. It's just.
Oh yeah, your sound way better. So go ahead, Liliana, you can speak now. We'll wait for Peter to put that up there.
Oh, I was just going to say that just regular globe scientists have acknowledged that there's approximately 12-minute difference in the length of our days. So in other words, on July 3rd, let's say, on the Tropic of Cancer, the day will be actually about 12 minutes longer than it would be in January on the Tropic of Capricorn. Did you understand me? So in other words, the summer day on the Tropic of Capricorn is 12 minutes shorter in December or January, early January, let's say, or late December. That would be basically the solstice, right? It would be the summer solstice on the Tropic of Capricorn. But that is 12 minutes shorter their day than it is in July 3rd, let's say, on the Tropic of Cancer, which would be the summer solstice in the northern hemisphere. And the reason they give that, the globers, the reason they give that is because of the aphelion, which happens on the 4th of July, 3rd of July, and the perihelion that happens on the 3rd of January. So basically what is happening is that the sun is moving faster on the Tropic of Cancer in July, but it's also higher in altitude. And then on January 3rd, when the sun is on top of the Tropic of Capricorn, it's moving faster, but the sun is lower. So the sun is not just rotating at the same altitude. It goes higher and lower, because if it's moving slower, even if it's just by 12 minutes, if it's moving slower on top of the Tropic of Cancer in the summer, for Tropic of Cancer, then it has to get a little bit lower in altitude in order to have, the similar amount of heat, because it's moving faster on the Tropic of Capricorn in January. Did I make myself clear? I don't know.
I got you. It's a great point. The Globers would believe that during summer, Australian summer, let's say, the sun is closer to the Earth than during European summer. That is true. And it does have an effect, a measurable effect, that whatever millions of miles distance between the two. However, in our calculations, the one I just shared, by the way, you can click that link. Let me know if it works for you all. I am ignoring this because I am operating as if I were a Greek from 2,000 years ago with a Google Sheets. So I have an advantage over Greeks. I have Google Sheets, and I don't know about what you just said. Like what you just said, I don't know about them because I'm 2,000 years ago. So we haven't learned that yet by then. So we're going to make predictions based on just simplified calculations, and we're going to see how far off they are with observations. And if they are roughly match observations, then we will ask why are they not perfect? And then the answer to the question would be exactly what you said. But that we will learn 1500 years later, if not more. But let's go back to ancient Greece and do our basic math. You guys want to look at the spreadsheet? Should I walk you through it?
Yeah.
All right. So I can't share the screen, obviously, since it's on Twitter, but you guys can look at the link. So what we have here on the left, we have the numbers that Ken provided. So we have everything is in nautical miles, just for simplicity. So Cancer is 3990 and Capricorn is 6810. From that, we calculate in columns E1, in column E, we have the circumference of the Tropic of Cancer, which is 25,000 and change. And the Tropic of Capricorn is 42,000 and change, or almost 43. And that's 2 pi times r, right? Did I remember my math correctly? Let me see. Yeah, I got it right. So that's we
got
see
your
that
math right, bro. You was tweeting that TM about some apples. I'm about to tweet at you right now, bro.
Yeah. So we see that the sun needs to travel a significantly longer distance, right? 43 almost 1,000 nautical miles for Australia, let's say. I'm simplifying, and 25 for Europe. So then I took two cities, Sydney, Australia, and Atlanta, Georgia. Anyone from Atlanta in the house? Okay. So surprisingly, they are kind of sister cities because they're in the globe model. Pardon me. They're 33.8 south, Sydney, 33.8 north, Atlanta. And unsurprisingly, the Globers claim that the amount of sunlight that they get during the day, during their own summers, is the same. I'm looking at my newly made friend here from Australia who may have disappeared to confirm that, but it's 14 hours and 24 minutes of delicious sunlight during summer. Awesome. They are not on the tropics. They're a little bit out by 10 degrees. I didn't correct that in my math. What I'm saying is that the linear velocity of the sun from our hypotheses would be 1,700 nautical miles per hour for Sydney guys, minus the correction for their distance from the tropics. Just to simplify, they could travel to the tropic, make some effort and go there. So 1,700, and for Atlanta is 1,000, right? So we have 70% difference in the speed of the sun going over our heads. That should be very noticeable. That's almost double the speed, correct? Well, 70%. So we'll wait for the observations from Ice-T and Alan, and we'll see if they confirm a 70% difference on the tropics. But even the people in Sydney and Atlanta, they should see a big difference, even though they're not directly under the sun during their summer, but close enough. So we can also make observations from those cities. That'd be cool.
Yeah, but they hide the true size of our known lands through
No, but
time
Ken knows.
zones.
No. Time zones have nothing to do with it.
Yeah, but I'm just saying they do this. So we don't know the true shapes of the land masses. We don't know the true sizes. We don't know the true distances. This is where that we're deriving based on a flat plane. But it's still up to us to go ahead and map everything out, which is going to take time. So, we can take it step by step, but it's only so far we could take. So far we could take it. But just real quick, I want to read something that Alan posted. And just real quick, Alan, so on Twitter Spaces, just so you know, because it's your second time in Flat Earth Friday. Shout out to you for pulling up. We could share all tweets to the top. We call it Jumbo, the Nest, right? So when you go to a tweet, I shared yours. It says sun speed. If you go to the share button on that tweet, it'll say share to the space. It'll probably say sacred space, something like that.
Oh, that's where the share thing is. Okay, cool. Thank you.
Right.
I'll do
So
that next time.
Yeah, I don't know what it looks like. I don't know if you're on PC,
Yeah,
but
I'm
you
on
also
PC.
shared a dope upload from YouTube, and you'll see it right now. So unless you want to do it, matter of fact, let's do that right now. Go to that YouTube link that you shared. I want everybody to go watch that too. Save it to your playlist. It says ADL Live, the Sun, Eratosthenes, Sun Angles, and Magnetic Flat Earth. So Alan, if you go and hit that share button, I'm gonna retweet it. But if you go and hit that share button, do you see anything that says share to the space?
Yep, done.
All right, let's see if it populates up top. So I shared Sunspeed to the left. It should pop up on the left
Yep.
in a second. I don't know if you guys can see it. I don't see it yet. Well, while that populates, I want to go ahead and read a couple of these documents that Alan shared. I guess this comes from a
Hey,
book.
Sacred, can I just say something real quick?
Yeah, go ahead.
So all that hard work I did, all that gets me is there are time zones they're hiding it from us, and let's watch a video. We're not going to discuss the conclusions.
Well, I just want to make sure that my co-host knows how to use Twitter Spaces, and we're also taking this step by step. These were posts that was shared an hour ago, so I just want to make sure that we all have the full context of the conversation, so that way we can go ahead and move forward with what you want to speak about. Although we really are talking about ethereal physics, so we did divert away from the topic at hand to address your questions for the past, I don't know, 2.5 hours. So hopefully you do appreciate that. But this is really about the instrumentation, Michelson-Morley, Michelson-Gale, Aries failure. We really want to talk about.
I appreciate that. I appreciate the opportunity.
Yeah.
Science takes some time, so
Right. But Alan, yeah. So if you see up top, your YouTube link populated, so everybody in the space can go check that out. Oh shit, am I rugging?
No, we can hear you.
No, you're good. We hear you.
Hold on, I am. Give me 1 second, guys. I'll be back in like 10 seconds.
I know a couple people had their hands up, and we've been going back and forth. Did you get that up? Oh yeah, Alan got it up there. Awesome. That. Did Xavier want to chime in, or were you gonna continue, Alan? I know we're still going through Peter's points right now.
Oh yeah, I'm good. We're just chilling. I was waiting for Sacred to get back.
What's up, Mr. X? Oh, and Rufus came up here. Rufus, what's up, y'all?
Can I say something real quick?
Yeah, you can take it.
Oh, just real quick. Yeah, I was just going to say that you can use some of the Glober science to debunk them, and you could do that. For instance, like they have to make some kind of a reasoning for what clearly, we can see is the circles are not the same size, right? Because the circle around when the sun is on top of the Tropic of Capricorn is going to be slightly bigger than when it's on the Tropic of Cancer. So they call it aphelion and perihelion because scientists can also measure that the sun is actually closer when it's on the Tropic of Capricorn, and they can measure that it's more distant when it's on the Tropic of Cancer. And so they give you this BS about, having a 3 million mile difference between aphelion and perihelion. But really all it is that the sun is going higher and lower in altitude as it makes bigger and smaller circles to so that the amount of heat that the land is getting would be ultimately pretty much the same. You know what I mean? Because if the altitude of the sun was exactly the same, then it would be way hotter on the Tropic of Cancer because it's moving slower. Anyways, I try to do this a lot where I use the Glober science to debunk themselves.
No, they don't like that. Not even a little bit. We had Globers come in here and say, you must not be flat earthers if you're using physics to debunk physics. But we talk about that a lot. And that's another thing that we like to kind of introduce to newer globe earthers, globe skeptics, the fact that in wintertime, or what's reported as wintertime, the sun is actually closer to us. And that doesn't really align with what sounds like it would make the most sense. You guys were talking about the distance of the sun, or like the widespread of the sun. I've been doing little observations lately, and for me, where I am at like 4 p.m. in the afternoon, Tokyo is getting sunlight. So me and Tokyo share the same sunlight at a certain part of the day, and I just can't wrap my head around that. Like, that seems astronomical when it comes to the shape of the Earth that they want us to believe, and the size of the sun. It's just crazy. So I definitely think we should keep looking into the sun. And who knows, maybe we could determine that the continents don't really align with the way that we receive sunlight.
And whenever in doubt, just claim refraction. You know what I'm saying? So that's the fix all. That and gravity. No, but hey, what's up, everybody? What's going on? I just wanted to say I was gonna uh, bring something in on Stationary Saturday, but that could come later. But I kind of wanted to well, Leela just said it though, because people were just ignoring what she was saying earlier, is that the sun is an apparent position and an apparent size that could be at different altitudes. So if you're pre-assuming, you know what you do when you assume that it's at the same altitude, then you're doing your calculations wrong. Nobody said that, and she cleared it up before I had my hand up. So just ignore the second half of this. But yeah, you gotta not use presuppositions with some of this stuff, so then your math is completely off. And another thing that Peter just to, you said you're not arguing for the globe or against the globe, and then you said, we at the globe side. So you kind of double speaking a lot during this stuff, and I understand why. But you were on my space the last time, and I asked you a couple of questions, and you said you completely agree with me. I have no counter argument, but let's go on to deflection to something else. So you could understand how you're frustrating, saying you did all this work and nobody's addressing it. So if you can't take the heat, get out of the kitchen. You're getting a taste of your own medicine.
That's
secondly, sir, Facing said the right thing. Earlier, you brought up the scientific method that only deals with cause and effect, and you misused the verbiage of cause and effect. So we talked about induction. I know you know what induction is versus deduction. You were in my space. So you're inducing the apparent size. Bradley talked about a method of triangulation, which is what he was getting at. You only know triangulation when you know the actual distance, the actual size from the sun. All we know about the sun that we can definitely know is that it's apparent. We don't know if it's a physical object, if it's an aberration or a reflection off the dome. And Alan brought up a good point about Dave Wise. He has really good videos. I didn't know you guys were talking about the sun. I would have brought them, where he has a light source outside of the dome, and he shines inside where it can be viewed at different areas. So I'm going to speed this up as the videos start. So it's sort of like a rainbow. If you're inside this thing, if you're looking at a certain direction, your distance away from the light is going to be different from somebody else's. So you can't triangulate it because it's in your own personal atmospheric dome, so to speak. And he has a video about personal atmospheric domes. So understand these can't be actual distances. They're apparent distances. And like Leela pointed out, these apparent distances can appear at different heights and different altitudes. So there's a lot more things to consider before you go ahead and inject globe math with something that we know is apparent.
Can I just respond real quick, not to all the points you made? What I'm doing here, I'm using the method that you outlined on Sunday, which I totally agree.
No, you're not. No, you're not. No, you're not. That wasn't my method.
I'm sorry. So, okay, sorry. So let me explain what I'm doing. I'm making a hypothesis based on the model that I was presented. And I am making some basic predictions based on that hypothesis. In that hypothesis, there are two claims. Well, yes, that the sun during solstices travels around two different circles. There's no claim about the height of the sun, its nature, its shape, anything to do with it, other than that it travels around two circles. and that in both cases it takes 24 hours for it to complete a full rotation. That's the hypothesis.
You are making a claim whether you know it or not, because if you're telling
No,
the
I don't
distance
know
of
it.
these, so
I don't
if you
know
know
it.
the distance of these circles, do you know the distance of these circles, the circumference?
I was given, I asked the community many times, and today for the first time,
Do you know
I was
when you
given,
said
yes.
when you said it moves, are you talking
Yes.
about a physical object?
I'm talking about the source of light.
So you don't know the source of light. Like I said, it could be an aberration or reflection, or it could be its own point source. So you don't know the source.
I do not know that, but I was given a model by Ken and by
Were you though?
Mr. Rufus.
Or were
Yes.
they just answering your specific questions?
No, I can show you the video that Rufus gave me that shows
So
exactly
you went from
that.
Rufus to Ken to somebody else. You took in a mishmash of different.
No. I went from Rufus to asking him for
No,
the
because
numbers.
earlier you said you got a TikTok from somebody, and nobody here has a TikTok that I know. So you went from
Rufus, sure.
TikToks to Ken to Rufus to you're all over the place. You're making a spaghetti salad with some.
I'm sorry.
Some different recipes, some
myself.
meatballs, and some hummus.
Right. You're right. Let me correct myself. I apologize.
No, you don't need to correct it because Alan has a lot of things here, and we were blessed with the times that he has here, and it's great that you have questions. But I had a lot of questions for him because it's rare that we got them.
Okay.
So
rather
than going all over the place, I rather a specific question.
Hey, can I hop in real quick and I won't take too long, and then I'll dip out so we can get on with the topic. And sorry to interrupt.
No, what up, Rufus?
Peter
did say your name a few times.
What up?
You pulling up just like a level head. I respect it. What's going on, bro?
Yeah, I don't usually hop up and speak in these spaces, but I felt a little bit obligated to just kind of give some background to what Peter is speaking to. Also, I appreciate the iced tea references, bro. That's pretty cool. What basically, like, it was a tweet that I put out, and it wasn't meant to be a completely accurate depiction of the way that the sun moves around the earth, but it was supposed to be a diagram that kind of gave a general example of what happens. And first off, I just want to point out that I think that the globers kind of get a little bit confused about the dispersion of the light rays from the sun, because they look at it from the fact that they think that the sun is a sphere, and it would disperse the rays completely differently if it were a sphere, as opposed to, I don't really know what it is, but it seemed like some sort of disk to me, but I'm not going to make any claims on that. But what I was saying is basically that the point I was making is that during the winter solstice here in America, where I'm at, the sun, like, basically right after it slows down, or right after it goes down, it gets completely dark afterwards, like pretty much instantly. And then in the summer solstice, the sun, it gets once the sun goes down, the light still sticks around for an hour, 2 hours afterwards. And
you get longer twilights.
Exactly. But the phenomenon that happens is that during the summer, in places that are along the outside of the sphere, the summer twilight is very short in the summer, and it's long in the winter. And that just gives evidence to the fact that it's moving faster during that time of the year. Another thing, just give me 1 second here.
I like that. I never thought about that, bro.
Yeah, dude. And that's just kind of like going from the Greek perspective, like Peter was claiming, is that we kind of go off the observations that we see in real life. And I'm not from Australia. This is just what I've been told and what I've read about, but they're from pretty credible sources. So I don't doubt them too much, but I'd have to go there to figure it out for myself. But there's another thing that happens, which I don't know if everyone here knows about or follows the track of the moon, but it kind of lends to the fact that this system had to have been created somehow. Because if you follow the track of the moon, it basically emulates the same path of the sun during different times of the year. So when you get to the first quarter moon, which you can observe tonight, it's about a first quarter, and it's a lot easier to follow the moon than the sun because the moon isn't like blinding you and you can't just sit there and watch it. But during the first quarter moon, the moon actually tracks the path of the sun, what it will be 3 months from now. And then the last quarter moon tracks the path of the sun, what it will be 3 months in the past. And you can go out there tonight and take a look at the moon and follow the path of it. And you can see that it's much lower in the sky because it was actually following the path of what the sun is going to do in 3 months from now. So that'd be like January. And last month it was real low. And I noticed this because a lot of people were saying, man, the moon was just out and now it's gone. It's because the moon is moving so much faster during that point because it was tracking the path of what the sun would be during the winter solstice. And basically, man, if you follow that out and you can just go out there tonight and see how it's moving a lot faster tonight than what it's going to be when it's 3/4 of the moon. And honestly, I really don't know where I'm going with this, but I think I gave you the information that I wanted to put out there. And those are kind of things that you can look into. But if this place was just a random coincidence, the moon wouldn't follow the path of the sun like that. And I'd love to know how the Glovers can explain, A, how the twilight is longer in the winter in Australia and it's longer in the summer in the United States, and also why the moon tracks the path of the sun. Thanks, Rose.
Ooh, I like those questions. And I wish we had that the tweet that you guys were referencing that kind of sparked off this conversation. If you guys
I
got
just
it.
shared it. I shared it under your tweet.
All right, that's what's up. I'm gonna put it up top. Anybody want to take a crack at a couple of those questions, Peter or Bradley, before we get to the hands?
Sure. I mean, I'm not sure what you mean by the moon tracks the path of the sun. I'm not sure if any of you caught the eclipse that happened a few days ago. The folks from NASA would tell us that the eclipse happened because the moon blocked the rays of the sun from hitting the Earth at certain specific locations on the Earth. And
this is a solar eclipse, right?
Yeah, this is a solar eclipse. And so I'm not sure what you mean when you say the moon tracks the sun. My understanding is that and somebody out there can correct me, is that you guys believe that a solar eclipse is not actually the moon blocking the sun at all. It's something completely different. And I'd be curious to hear what that something is. And there was something that Newsig had said that I'm kind of confused about too. He talked about personal star fields or something like that.
Personal star fields.
What was it? Personal, well, like
personal atmospheric grid of vision.
Okay. So that explains why, like, the guy from Australia can't see the North Star, and we can because we're looking at a different set of stars, or
it falls beyond your perspective.
It falls beyond my perspective.
It's too far away to see in basically because of perspective in Australia. But there are places on the Earth where you can essentially see the North Star and the path of the stars circling around whatever is claimed to be the South Star at the same time. And I'd wonder if anyone could explain how that happens either.
Well, according to the globe model, I guess that makes sense. If you're on the equator, you should be able to see. Actually, I believe you should be able to see both if you're anywhere a certain distance away from the equator, but I'm not positive about that. As far as
I heard you can kind of see some of those celestial poles all the way above the equator.
maybe.
And I don't know if that's to happen on a globe. But go ahead. You can answer real quick, and I do want to read something real quick before you got to go. But go ahead.
Can I say something?
Hold on one second, Liliana. Let me just I guess Bradley was finished. Thank you for whatever that was. But Alan, so what is this right here? I shared this tweet. It says sun speed. Seems to come from some literature titled "Eccentricity of the Sun's Path."
Yeah, so the text is from Gleason's book, where he talks about how he derived the sun's speed, the linear speed, as dude was saying. So I was showing him, if he wanted some numbers or whatever, to go check out Gleason's book at chapter 8. Highlighted the sections there. It's searchable with a PDF or whatever, so you can just Control F it and find the relevant section there and get all the information that you're kind of looking for. I think that'll point you in the right direction there. And then secondly, somebody said something about how the sun isn't a physical object and whatnot. So I put up some visual images of that. So those images there. There's two images. They're both of the same thing, but one's just more filled in. But what that is if FE Core took measurements of the sun, and if you plot them out for an observer at every latitude interval, right, and then you did it for the entire sphere and or plane, what you would get is, well, I guess they only did it on a plane. So what you get is the sun makes a 3-dimensional hyperbola in the sky. Like it's crazy. So that's what that is. It's not a physical object. It's an apparent location. We all see it in like slightly different spots. But when you plot it out and then wrap it, 360 degrees, it makes this 3-dimensional hyperbola in the sky. So it follows like a toroidal field pattern in the sky. It's basically is what it's doing in the sky for all observers every day, all day. It's pretty cool.
Bro, just beat me to Ethereal Physics Part 5. Get this guy out of here.
Dude, I wish Shane was here, bro. He would have crushed, man. The celestial star stuff in the south is like his forte, man. It would have been great. I don't have much on it. It's not my field of that I highly looked into. But yeah, Shane will come back next week and crush it. He'll answer all these questions about that stuff.
So these are for everybody in the space. There's a two tweets up top. One's in yellow, and well, they're both in yellow. But you can kind of see this toroidal field shape that Alan was referring to. And basically, like he was saying, like these are plots of every observer from all different places across the plane relative to the sun's motion, and it creates this toroidal field. So it's interesting that this shape is created, and we have this discussion about this toroidal field often.
Yeah, man, it's toroids all the way down, like your boy Stephen King said.
It is crazy, man. Yep. So these are all relative observations. So let me just read this real quick too, because there was some dope stuff on this one excerpt, and then we'll go ahead and get to the rest of the hands. So it says both science and scripture, as well as common sense, assert the positive fact of the diurnal revolution of the sun, as well as the rest of the planetary system only, with which Earth has no possible analogy. Neither is a latter identified with the former as a receiver of their benefits for which the Creator designed. The sun's speed in the spring or autumn equinox is of necessity just 15 nautical miles per minute or 900 miles per hour, that being the distance between meridian lines of longitude on the equator. In its lesser orbit in the June solstice 15 degrees from the equator. We say 15 degrees from the equator because we have proven in chapter 14, figure 25, that this is correct. North, its speed is proportionately reduced to 665 miles an hour and increased to the same extent in its December or winter solstice to 1135 miles per hour. So this was from Gleason, and there's a little diagram over there on the right, figure 30, if you guys want to check that out. I dropped out in rugs, so I didn't get to see who was next. I think Liliana wanted to chime in, and then we'll go to Jonathan, because I hadn't heard from him yet. Go ahead, Liliana.
Well, if someone else wants to go ahead, that's fine, because I can come back again. Or is it okay? I don't know. Does Jonathan?
Nah, go ahead, girl.
Oh, okay. All right. I just wanted to throw one thing out about the sun, since we were talking about the sun. Sorry about that. Oh, by the way, Rufus, you're absolutely correct. The moon is doing the same dance like the sun, going up and down as it circles, but we can get into that later. But anyways, what I was going to say was there's an elephant in the room that people have been talking about, just the general public, that NASA is not touching at all. And I just wanted to bring it to your attention. There's been, over the last 20 years or so, there's been like, well, actually the people that have observed this has only happened in the last 5 years. But there have been literally people all over the world, like the tribes, the Inuit tribes in the Arctic region. And then there's, citizens in the East Coast of USA, West Coast of USA, and other parts of the world have all noticed this. And what it is that they're all like this one guy in Massachusetts. He has been with the same job for 30 years, and he's been taking the exact same road every morning for 30 years. And he swears that the sun is rising 15 degrees north of where it did like 20, 25 years ago, since he's been taking the same road. And then there's a woman on the West Coast who inherited a house from her grandparents, or her parents, sorry. She grew up in that house. And she said that she swears, because she has been in the house, as a child and a teenager, and now she's, middle-aged adult. And she said that the sun is literally setting 15 degrees north of where it did like 20 years ago. And then even the Inuit tribesmen, they've all been saying like, yeah, the sun used to rise on that mountain, and now it's rising, behind this other mountain. And when they point the finger, it's roughly 15 degrees difference. And then there's another guy, I forget which part of USA, but he said that the sun used to come in from window, on the left. And then now, 15, 20 years later, the window is coming in from a window that is literally 10, 15 feet to the right. So it's very curious that NASA is not touching this subject at all. And I keep reading comments in different articles online when people leave comments. And a lot of these comments were left on the articles that were talking about the actual movement of the magnetic North Pole. So anyways, it's a kind of a long story. And I think I know exactly what is happening, because it makes total sense on flat Earth, but we can get into that later.
Lily, you're the best, man. And I know why they're not addressing it is because they know that we understand that we would feel the effects of the Earth changing position in relativity to the sun if it were to move that way. And since they say we're moving in a centrifugal motion and you can't feel any of the effects of the movement of the Earth, they just pretty much have to ignore it.
Yeah.
To ignore everything.
Yeah, I mean, literally, when they say the magnetic North Pole is moving, because we can get into the whole pole flip things, because see, the science does tell us certain things. Like you can read the magnetite, the magnetite particles in the soil and everything. And of course, you can tell by the direction that they pointed that definitely there has been pole shifts. But the reasoning that the globers give us, of course, is completely inaccurate. And anyways, there's a unified theory that I've been working on, and I'll share with you with that. I'll share that on Twitter at some point. I'm working on writing it all down so that it basically tells you the reason for all of this stuff. So
All right, appreciate that. Jonathan and Janice been waiting for a little while, but Jonathan, if you wanted to take it, you could go up next. Welcome to Flat Earth Fridays. What do you believe the shape of the Earth is?
Can you hear me okay?
Yeah.
Okay. The reason I asked is I'm plenty outside of the city limits of Indianapolis here, at a campground actually. So, yeah, so it's a pleasure being here, listening to the conversation. Very interesting. I am a Glober, and one thing I can say that I find interesting about these conversations is, first of all, is there too much noise in the room that I'm in right now?
Just a tad bit.
Yeah, it's a bit
background.
much.
Let me see if this charging cord is long enough for me to step outside this door here. I think that'll work. Sorry, bear with me a second. Okay, that works. So I'm a Glober, and I have all my life enjoyed playing sort of devil's advocate in my own mind. So there's a lot of things that scientists say that I disagree with as a Glober. I'm a young Earth creationist, so I pretty much have jettisoned all the things they say about evolution and deep time. The trouble here is that I believe in deep space, even though I disagree with deep time. So, but I've played devil's advocate many times, even with the heliocentric model, and I've tried to assume it's not right and try to prove it out in my own head, and I've enjoyed that. But what I wanted to say in this conversation was, first I was listening to what was being said about the sun having to take a longer path, a longer circumference, if you will, along the Tropic of Capricorn. And I found it interesting that it is a part of some of what some of you say that it's perhaps higher in altitude, and I found that interesting. And yes, that would alleviate some of the problem of, oh, well, then it would have to go faster across the sky. No, not if it's higher in the sky. So I found that interesting, and I appreciate that. I would add that then we might want to take a look at its angular size if it's higher in the sky. And that can be done with a $100 Newtonian telescope with the sun filter on the end. It would not be hard to notice that the sun is far enough away to appear to go the same speed across the sky, even though it is technically going faster. And so the other thing that I thought of with regard to the sun not being a physical object is I wonder what you guys think about sunspots, and if anyone in this community has tried to take multiple pictures of the same sun. It would cost some money to buy the equipment, but many of you have bought it out. So I wonder if anyone would be willing or has already taken a telescope and mounted a camera through it and taken pictures with a sun filter of sunspots throughout a single day or maybe a couple days, and see if you can string images together and watch the sunspot, see whether or not they're actually turning, see if you can actually notice the sun rotating, if you will, similar to how we claim the Earth rotates every 24 hours. Have any of you tried it, and are you willing to? I'll leave it at that.
So I actually have a telescope. It's not very powerful. It's not like top of the line, state of the art, or anything like that. And it did come with a solar filter, but I wasn't able to use it for some reason. I've looked at online videos of people who've zoomed in on the sunspots, and some of the videos you can see rotation, some of the videos you don't see rotation. I will say I've never seen a full 24-hour rotation, or I guess you would call it like the full sun rotation, if that's possible. That is interesting to me because I learned that the sun is not a sphere, it's like an oblate spheroid, but it's also a gas. So the sun itself, we have our own questions about that and how or why science treats the sun as a surface or like as if it has a surface. But yeah, I would definitely be down to getting a better solar filter to see the sun in totality the way I look at the moon. That would be dope.
There's
I
a
watched
guy.
the 2017. Oh, sorry, I watched the 2017 solar eclipse through a telescope that I had. I've since given it away because we ran out of room. And yeah, it's really amazing to see the sun through that, especially if you're watching an eclipse. Regardless of what we think an eclipse is, it's amazing to see, and to God be the glory.
There was a guy. I'm sorry. Go ahead.
I was gonna say the problem with the eclipse is the well, the solar one anyway, is the shadow that is supposedly casting onto the Earth. Isn't it too small?
Why is that a problem? I'm curious.
Isn't it too small?
The moon or the shadow?
The shadow's smaller than the shadow's smaller than the diameter of the moon.
They could excuse that with that umbra penumbra.
Umbra penumbra. Those words sound funny together. Like bibbidi bobbidi boo or something. Anyway, so yeah,
that's what it is. Sorcery.
Yeah, maybe somebody should use it as a handle. So I mean, I can picture it in my head. I know you've seen the diagrams of the shadow and everything. How the moon would, the moon's shadow would cone down. It would neck down until it got near the Earth. And depending on whether the moon is in perigee or apogee, you get a annular eclipse versus a full eclipse, as I understand it. So since the sun is bigger than the moon, it will. You can imagine that no matter how far the moon is from the sun, you're always going to technically get these converging lines from the farthest edge of the sun, if you will, to the same edge of the moon. And then on the other side, you'd get a similar line that would be converging. And it just so happens that the distance from the moon to the Earth, those converging lines almost touch by the time they get clear. So I know you guys are going to tear that apart or whatever, but yeah, go for it. I'm curious to see what you guys say.
Hold on, did you give your number one belief or proof why you believe in the globe model? I missed that part.
Oh no, I just said I'm a glober. But my number one.
He's a skeptic of science as well. Like he disagrees with some of science.
Oh yeah.
So that's pretty dope.
But my number one. Yeah.
Hold on, I got a lot of moving around, man. Tell gravity to chill up off you for a second.
Fight back.
Fight the gravitational waves. All right, we can hear you. Go ahead.
If I'm still speaking, am I still speaking?
Yeah, you were just moving around a little bit too much.
Oh, okay. Jumping topics around. Okay, well, I thought I was asked.
No, you were moving around too much. There was a lot of background noise. But yeah, we were waiting for you to tell us what your number one belief or proof was.
Oh, okay. My number one reason to believe the Earth is round would probably be the motion of the stars. And now, do you want a proof for the shape of the Earth, or do you want my number one proof for the heliocentric model?
Whichever one.
Okay. Well, for the heliocentric model, my number one proof is that I can go on to any number of apps, such as Eyes on the Solar System. I know that eyes are going to roll. But bear with me a second. So even though these are apps, even though this is computer generated stuff, it's still there's software running in the background that predicts the motions of planets orbiting the sun, and you can set the time and the date and the rate and all that stuff. And then you can zoom in on the Earth. You freeze time at any point in the future, say 10 years in the future, freeze time, stop the simulation, zoom in on the Earth, go to where you are, and at what time, whatever you want to make a prediction. Look up in the sky in that app and see where the planets are with relation to the other stars, and just, I don't know, draw a picture if you want to, but note the exact location and then wait that number of years and then look up. You can pick a time when the planet's in retrograde motion, something complex, something that's hard to predict. And I would bet that it would be right on the money. And so that just tells me that this heliocentric model is simply accurate. It couldn't make those predictions if it wasn't. I have a flat earth friend of mine, and we have great conversations. And that's one of the things I'm hoping he will do, because it kind of stumps him. It's like, yeah, you do have a point there. So that's probably one of the most compelling things that
I got
would
you,
agree
homie.
with any of you.
Get him, Alan.
Okay, so in regards to the heliocentric coordinate system and its correctness and predictive abilities, so there's a book called the Supplemental Ephemeris and it's the Supplemental Nautical Almanac and Nautical Ephemeris and all this stuff, right? And basically what this book is it's a book written because people were asking, hey, how did you get all these corrections and angle corrections for the globe and all this for the Nautical Almanac and for the traverse tables for navigating and stuff, right? Because celestial navigation tends to match with maps that match the so-called globe, right? So check this out. In this book, they go over in detail everything. Now, basically, the difference between the globe and a plane comes down to what they call the deflection of the vertical. So if you're not familiar with what that is, they're basically saying that if you have two poles that are straight, parallel with each other, that one will be tilted, that they'll be tilted slightly away from each other due to the curvature of the Earth, kind of thing, right? So it's like, oh, cool. Well, how much is the deflection of the vertical? Well, when you get into the arc of the parallel and all that, that's where you get their spherical axis and stuff. So the difference between a plane and a sphere and the globe that you think that we live on is a difference in arc seconds that it's not even an arc second, it's fractions of an arc second. It's like 3 or 4 decimal places behind what an arc second would even normally be, right? So it's just absolute minuscule. So the important thing to note, though, in this book, though, that they go over is that they have 2 different coordinate systems that they're using to make the geocentric coordinate system. And the way they kind of present it is that the heliocentric coordinate system is the correct one, and that it's the first one, actually, right? But then when you look at the math they use, you see the transformation equations. Well, they're deriving the heliocentric perspective, center of the ball and all that sort of stuff from the geocentric coordinate system. So the geocentric coordinate system mathematically supersedes the heliocentric one in terms of like which one came first, just by function of the perspective of the heliocentric way that they have it modeled out. I'll have pictures to go along with what I'm talking about, just so you can see the difference between the 2 coordinate systems, because it'll blow your mind. It's literally just a quick math equation that they just slip in there. So anyway, what they did is they went around the plane and took measurement angles, basically planar elevation angles to Polaris, right, starting with that in the north, and then as they got further away, they just plotted out, what kind of correction angles they would have to make, and all of that is done from their geocentric coordinate system. And then they have their an equation that they use for corrections. And in this equation, what they can do is they can either flatten or they can add ellipticity. So I'm sure you've heard the term, we live on an oblate spheroid and all this stuff, right? And how oblate is it? Where's the flatness? Well, funny you mention it. So this entire equation is facilitated on transferring planar correction angle measurements to the spherical coordinate system. So they just add a little what do they call it? Can't think of the word. Starts with an E. It's basically the curvature of the Earth is basically what they're adding, right? So they can flatten or curve whatever they need to on that coordinate system. And I'll have the pictures for you in 1 second.
So basically, not only because basically what Alan was saying for all of those who's new to hearing this, if you're on a plane, there may or may not be any deflection, but on a sphere, you'll have this angle from one point A to point B. And they'll say that this is spherical excess because it'll be pointed away from each other. But that differential after they make their corrections in a presupposed ellipsoid or a geoid
Ellipticity.
ellipticity is fractions of an arc second. Fractions after the corrections. And not only that, they derive their coordinate system, heliocentrism, from a geocentric framework where everything revolves around us. So just imagine, like, how easy would it to be to do that and pull the wool over our eyes? Like, it's so crazy. Go ahead, Alan, you want to finish up?
Oh no, you're good, bro. You're killing it. I'm just copy pasting pictures right now to put on the Jumbotron.
That's what's up. Please share the visuals. And then what I'm doing, I'm gonna take those same tweets up top and I'm gonna link them in the thread so you guys can double back and check these tweets out later. So just think about that, bro. Like these are these guys. If this is really what they did, the deception goes so deep.
Yeah, the difference between map and all that, because you got to think too, it's all in cycles too, right? So when you were saying earlier about how you can project out like 10, 20 years, well, they were doing all that way back in the day when all these ancient civilizations were flat earth cosmologies. The Babylonians were flat earthers, the ancient Hebrews, Israelites, all that, flat earthers, dog. And they were all doing eclipse predictions and all that stuff. They were all basing that.
Mesopotamians as well.
Not true. That is not true.
Oh yeah.
Yeah, it's not.
Okay.
I mean, I
Did
looked at
Bradley
this
just say
because
that?
yeah, thank you, Sacred, for exposing me to this, because I didn't know 4 weeks ago I didn't know a thing about this, and you told me all about the Saros cycles and all these ancient civilizations that predicted eclipses, and I read an awful lot about it, and I learned an awful lot, and I owe it to you for pointing that thing out, because I didn't know any of this stuff before. And the reality is that Saros cycles can predict that if an eclipse happens, a little more than 18 years later, another eclipse will happen somewhere else on the globe. They could never tell you exactly where. They could never tell you exactly when. And if you wanted, eventually someone figured out that you could get an approximate location if you assumed that the Earth was a globe and you realized that the Saros cycle was off by a third of a day. That meant that you could take the location of the previous eclipse, rotate around the globe Earth 120 degrees, basically a third of the Earth, and that would be the line on which the eclipse would show up. But they could never do what we do today. I mean, you go on to the NASA website today, and they will tell you to the second where the eclipse will be, how long it'll last. They'll show you the line. I mean, the amount of detail that is available today does not, it's incomparable to what the ancients were capable of doing.
During your research, did you come across the Antikytherian mechanism?
Yep.
Okay, they had all that. They had all of that plotted out on a stationary plane. The only difference
what is
is
it called? The
Antikytherian mechanism. I'll link a video to it in a second. The only difference between the predictions made on that device and a globe is they took the turning of the wheel to spin it, and they just said that we're the globe spinning. Like there's no, it's all on a flat Earth, bro. Anyway,
they were never able to plot the path of the shadow like they do today. Never. There is not a civilization that was able to tell you where the eclipse was going to happen.
And who told you that? The current civilization? That's that.
No.
I'm
Okay.
just with you, bro. You're good.
You're claiming something. Okay. You're claiming that ancient civilizations had this ability. I may be wrong. I admit that. I could be wrong.
That's all good.
All you have to do is show me.
Yeah.
Okay?
So
show me a record from an ancient civilization.
I got you. Go back to the NASA website where you were looking for the eclipse predictions. Control F and look for Fred Espernek. When you look at that guy, you'll see how he derives all their eclipse predictions. They don't predict a single thing. Your boy Fred Espernek predicts them, and he does it based off of basically eclipse pattern tables from ancient civilizations that were all flat earthers. It has nothing to do with a glob and turning it 100 degrees. That's all heliocentric mythology, my dude. But it's cool.
You cannot get those numbers without assuming a globe Earth.
Word.
You can't get those numbers.
Okay.
You just can't. I mean, I don't know any other way to explain it.
Yeah.
Bradley, that's a claim. You can't make a negative claim without substantiating yourself, man.
Dude, but he can't explain it, so it's all good.
Anyway. Here's the thing that I can say, though. You need to provide evidence that the ancients were able to do what NASA can do today.
Fred Espernek's tables are referencing to the ancient Babylonian stuff, all the stuff that I'm talking about. All of their cosmologies, all the data tables, all of that comes from there.
Yeah. How old is Fred?
I don't know. Still alive.
Is he still?
What does it matter?
Because he didn't live 3,000 years ago. That's the point. Okay.
You don't have to. You have it
again.
You didn't have to. You predict the Big Bang. Did you live in the Big Bang era?
Hold on a sec.
That's a shitty argument.
Hold on a sec. Don't dogpile. I got
it. You guys are making a claim that the ancients were able to predict a precise location of eclipses the same way that we do today. And I'm saying, prove it.
Yes.
Show me.
Fred Espernek uses all of their data to make the predictions. It's an algorithm, bro. It has nothing to do with a glob. Like you got.
He did not. Okay. I have.
No, Alan. No. Don't you like this level of discourse, Alan? Everything you come up with, he just says no.
Dude, I sure don't.
Isn't that profound, dude?
It's running its course, but we're good.
No. It's okay. You guys can mock me for.
But you need something more than no.
I just gave you straight
where to go research.
I just gave you straight facts, and you said no. Okay. So what's up?
If you don't interrupt me, maybe I'd be able to say something. Okay.
Continue, please.
So what you're claiming is this guy did exactly what the ancients did?
Yeah, NASA claims that,
what you're
bro.
Claiming?
Not only do I claim it, NASA explicitly claims it on their websites. They make no predictions on the eclipses. Okay. They put it all on Espernek.
Post it, dude.
Okay.
And I'll look at
it. Google it.
Got you.
Unlike you guys, I'm willing to admit when I'm wrong.
Yeah.
And
but you're not willing to substantiate your claim, dude. When you make it's better you say, I'm not sure of something. Do you have any evidence? When you say this cannot work on a flat plane, that is a claim. That is a claim. You have to provide the evidence. You don't say, prove me wrong after you make a negative claim. You got to substantiate your negative claim. So if you're not going to make a claim and substantiate it, don't make the claim. Just say, I don't know if it's true or false. Do you have evidence to support?
Okay. You can't prove a negative. You can't prove a negative.
Yes, you can. You are not in this room right now. I looked around. I checked underneath the bed. You can prove a negative. It's the default position. That's a common misconception. The default position, you don't need to prove. A negative, you do. You are wrong.
Position that the Earth is flat?
I don't know what the shape of the Earth is. That's a default position. To say I know the shape of the Earth is a sphere, or it's a cube. That's a positive claim. It is not a cube. Is a negative claim. All of those have a burden of proof. I don't know what it is. It could be this or that. That's a default position. You're not making an affirmative claim, nor are you making a negation.
You're just saying you don't know.
All right. I posted 2 links. One is to the eclipse, NASA website, and then the other is a screenshot at the bottom where all eclipses and calculations are by Fred Espernek, and he assumes all responsibility for their accuracy and their information. And then it has citations for all the tables that he uses to make the quote-unquote heliocentric predictions that could only work out on a glob. Anyway.
Wait, say that last part again.
GG's.
Exactly what you just repeated.
Yeah, what'd you just say?
Fred Espernek. I just added on the same thing that you said, but I added it on as if it was a heliocentric truth. But anyway, check it out. Highly recommend. Anyway, what was your other big one that you liked?
A quick intervention. interruption. I wanted to say something about his question about the sunspots, whatnot, but I can come back.
My bad, guys. I was just looking at some of this content that Alan put up top here.
Oh yeah, sorry. I also included the transformation stuff in some excerpts from the book, and so you can kind of see what they're doing. So the big important thing to note on the screenshots, if you see the spherical picture and like the cylinder one, so on the left hand side, that cylinder would be the geocentric planar coordinate system, and then on the right would be the heliocentric perspective uh, that they use for the quote unquote heliocentric predictions or whatever, right? But you can see that the difference between those is literally just a transformation, and the perspective of the center of location of the ball and all that is derived from the geocentric coordinate system. Anyway. But yeah, that's how they got us, dude. They just did a bunch of transformations over a small, minuscule number, and they said it wouldn't be possible if it was a flat Earth. And it's like, not only is it super possible, the difference between the two models is fractions of nothing. Of fractions of our imaginations, really, dog. Because actually, the margin of error exceeds the spherical excess that they try and claim. That's the excess in the sphere, which is crazy. Because what they do is they take little small triangles and then they add them up together to make like a big triangle, using air quotes there, and then they kind of like hide their margin of error, and they're like, oh my god, wow, it's spherical excess. It's not. It's not. So.
Do they do the weighted value thing too?
Oh, weighted as fuck, brother. They weight that value the hardest. So great. Yeah, dude, it's the best. And so the weighting actually gives the appearance of them. So they'll be like, oh, well, we got these raw measurements. We don't make any corrections. It's all raw data. It's like, yeah, dude, but it's like weighted. So like what, like nice literal false equivalence, right? So it's all good though. It's all good though. We're learning. We're all waking up to the deceptions and stuff, So
Damn
it's
right.
all good. They hid the sphere in there for a hot minute, dog. But now that we can control F search documents for keywords and then go from there, we just annihilated the 900-page document in like an hour and a half one day. It was awesome. Rest in peace, spherical excess. You had a good run.
Shout out to y'all for giving us technology again.
Yep.
Shout out to the engineers. Science likes to take credit, but it's usually people like Tesla that come out with this stuff. I wanted to ask a question, Alan. Earlier you talked about GPS, and one of the things that they tried to correct for it, you said the SAGNAT effect is usually trying to make apologetics for the. Could you elaborate on that a little bit?
Yeah, so the SAGNAT effect and the SAGNAT correction are two different things. The way that they attribute the variance in GPS is they call it a SAGNAT correction. And the way that they're trying to associate the terminology, I guess, is through rotation. So they're saying that, like, the Earth is rotating and the SAGNAT effect is due to a rotation. So I guess that's kind of like the wordplay they're trying to go with right there. So what happens is that the GPS will send out a signal to a receiver, and it takes its first measurement. That first measurement is done in what's called the ECI reference frame. That's stationary non-rotating reference frame. It's basically so that they can, it may or may not be where we live, right? And then so they get this distance from that based on what they think is, the fixed speed of light, and then they transform it to the ECF reference frame. And when they do that transformation, it should be an invariant transformation because the speed of light, it should be fixed for, blah, 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 reference frames and all that shit that they say. So the transformation should be invariant, meaning that it adheres to Lorentz symmetry. So like we've all heard these things like all reference frames are equally valid. There's no special reference frame. It's like, what does that mean? Well, the first postulate of special relativity is talking about Lorentz symmetry when it says that all reference frames are equally valid. What you do when you transform coordinate systems, you take the laws of physics with you, right? And the laws of physics have to be unchanged under transformation. So the way that GPS is specifically set up, being a time interval system all synced to the same time, and the assumed speed of light having a fixed value, this should the distances should transform invariantly, right? So it shouldn't have any problem. That they should be able to map it on a globe, on a triangle, on an oblate spheroid, rotating, not rotating, oscillating, vibrating, doesn't matter. The distance will be the same because the speed, under their assumptions, the speed of light is fixed, and the time interval system is synced precisely to the same time, which they've done a really good job of synchronizing it with. So this should absolutely 100% produce an invariant transformation, and it doesn't. It shows that there's a variance, and they call the corrections that they make to it segnet corrections, trying to associate it with some sort of angular rotation, blah 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 sort of thing. But that's not what's happening. What the way that GPS actually works is that the velocity of the receiver is already incorporated into it with the range measurement equation, and there's a proportional delay in which they receive the signal propagation, and it's proportional to their speed. So it's like literally as if there's a medium that electromagnetic waves is propagating to, and your speed relative to that medium is how you're going to receive electromagnetic propagation, like a variance relative to your velocity through that medium, the same way that sonar would work in water. So it's like, hands down, like one of the best proofs we got. Once you unravel that big snake's nest or whatever you want to call it. So yeah, there's there's a bunch of papers by a guy named Neil Ashby and a couple other people, and they go around promoting this segnet correction, GPS, Earth rotation situation kind of thing. But when they look at, there was two dudes, Petit and Wolf, who did a paper analyzing GPS data, and the data that they already got was segnet corrected, so-called, and they mentioned that in their paper. So like, even on the it's just so bad for them that they have to make a correction to that, because these are first order measurements, and if the speed of light was fixed in the way they said it did, it would be an awesome proof for them, but it's not, and they don't talk about this, and this is how that like the inner workings of GPS falsify everything they say, because this is explicitly how the technology works, and most people don't understand the intricacies of the time interval system and the transformation equations, and the fact that they take it in two different coordinate systems to do the measurements and then transform it, and they break Lorentz symmetry, and then they just don't tell anyone. Guys, they just don't tell anyone. How do they keep getting away with it? They're not going to tell you that they messed up, guys. And this isn't for like the flat Earth crew per se, but this is more for like the globe skeptic people that are like, how would they do it? Like, they're not going to tell you when stuff like this happens. They're going to try and obscure it. They're going to have Neil Ashby going around for 20 years, going to every publication saying that the segnet correction is due to Earth rotation. And it's like, okay, dude, cool story. All right, that's my 2 cents.
I found that one of the biggest things to make me help consider ether was GPS and the atomic clock, the propagation. I'm sure you already know about the twins paradox, which is completely broken.
Yeah.
So the medium is a better explanation. I won't go through that, but I wrote down what everything you said. That was pretty cool. Thank you. Do you find that they replace a lot of the theories that they replace? It's gonna like they do away with the ether, but not really, right? They split it up in layers between the field and quantum foam. So every attribute of the ether gets split into different layers. Have you found out that you have to piece stuff back together from the standard model to get ether back?
Yeah, dude. So there's all kinds of like little low-key references to ethers and vortexes and stuff like that. So I'll send a couple of screenshots here after I talk about this. But yeah, so there's to start off with, there's the what is it called? The Bose-Einstein condensates, which is a vortex lattice structure that forms in a spinning quote unquote particle when they cool it down to a super cold, whatever that means. Basically these little lattice structures start to form when they try and spin the particle, whatever that even means, right? And there's screenshots here that I'll show. You can see these like these little vortexes start spawning inside of what they're looking at. It's crazy. So they got that whole thing going on, and then they also believe in something called the heliospheric current sheet, which is an interplanetary electromagnetic field or whatever that's generated from the sun that interconnects all the planets, and you'll never believe what it looks like, a giant vortex emanating from the sun, and it's very cool. But it's like, saying that there's an ether that requires electromagnetic propagation, they're like, no, can't do it. It's like garlic to a vampire. It's very bizarre when you see when you see the overlaying concepts with like a Higgs field and all that and quantum field theory. So for quantum field theory, they're like, okay, if we break every known substance down into like its own stationary field, and then when it's a particle, so called, that means that there's a vibration within that field, and that's when we observe like physicality to things, right? So like particles and whatnot. And so it's like, oh well, what's stopping us from like exploring this stationary field situation further? It's like, well, it doesn't work with our concept of gravitation, mass attracting mass, or the bending and warping of space time, dark matter and antimatter and dark energy and all that. Like, it doesn't work with any of that stuff, and we all know that stuff's true because otherwise heliocentrism wouldn't be true. So we can't really proceed forward with quantum field theory other than just to say it's a nice predictive model to say that things are in a field, just for funsies.
Hey, I got some questions as I'm looking at this stuff. Can I interject, or do you want me to do it?
One second, Bradley. I do want to hear from you, but Unknown has been super patient. So let's hear from Unknown real quick. I appreciate that, Alan. And Bradley, just keep that whatever you have to say in mind. Don't forget. And we'll double back to you after we hear from Liliana. But go ahead, Unknown.
Hey guys, thanks so much for bringing me up. I've just been listening for 30 minutes right now, and I don't know if somebody already asked this question. I'm actually believe in a globe. I went through the indoctrination system of the education system of the West, and I was taught about the way they came about the globe model of the guy who was in, I don't know, Europe, who put a stick in the ground and took the shadow and did a stick in the ground in Egypt, and that's what I was taught. So I've been getting a lot of flat Earth stuff in my feed as of recently, and there was one question that made me doubt or think was there's a massive black hole in the center of our galaxy, and then our sun is flying through around this black hole at, I don't know, some super fast speed, and then our planet Earth is rotating at a super fast speed, and then the moon is rotating around our sun without ever showing the dark side of the moon ever, and then the gravity of the sun is holding our planets, and they're all rotating and flying around the sun while it's flying around the dark hole. So I don't know if my question is appropriate for the people on the stage here, but if maybe somebody could enlighten me on that stuff. I'm just honestly learning from what you guys are saying and what you guys got up on the jumbotron there. So that's my question. Thank you.
Lot to unpack there, my dude. Let's see. Where should we start off with? Eratosthenes and the sun. So I got a really good video you should check out for Eratosthenes and the whole narrative behind that. So there's the problem with the Eratosthenes thing, and the way that they solved it was by saying that the sun is 93 million miles away, and there was no justification for doing that. And then from our perspective, where we say it's not a physical object, like we explain the same situation, but just with a different mechanism, right? So we have the azimuthal grid of vision. So every person will see the sun, relative to their field of vision. So there's gonna be like a slight displacement. So the kind of the imagery that I linked earlier, where the sun, when you plot it out to the latitude, makes a 3D hyperbola in the sky, meaning it just makes a big donut in the sky if you were to plot it out to the latitude and then over 360 degrees. So it's not a physical object, and kind of coming to that understanding really alleviates a lot of the I don't know, like where you're trying to hold on to, like, well, how is it 93 million miles away, and how are the shadows and the parallel rays and all this stuff, and it's like there's no justification for it other than the ad hoc explanation of it being 93 million miles away, based on two shadows, right? So like no third shadow or nothing, right? But then like I said, when you get into the third shadow, that's where they just move the sun 93 million miles away, and that's where we're starting to come to the realization that we have an azimuthal grid of vision meaning that each person has a local field of vision, and what you see is, in the sky is going to be put in your field of vision relative to where you're at on the Earth. Oops, sorry about that. Hit my mic. So your other question about black holes and stuff. So let's talk about the concept of a black hole, right? Because that would be the underlying mechanism that's facilitating all of this motion, right, so to speak, within our local galaxy, right? So the concept of a black hole comes from something called a singularity, and that's when the mathematics break down in an equation. So a lot of the big common equation that they use for a lot of space-time stuff and Einstein and whatnot is they use what's called the Schwarzschild metric. And the Schwarzschild metric has a certain what's it called? What's the word I'm looking for? I don't know. I can't think of the word, but it has a certain like limit on what it can describe, right? In terms of mass and size relationship, right? And if something goes below a certain point in size, and if it's due to how gravity works and all that, as it gets denser, it breaks the equation basically. So it gets too dense, and then the gravitational field, quote unquote, breaks the equation. And they describe this in this like eloquent story of like the curvature of space time becomes infinite, and we don't know what happens, and there's this singularity, and it's so strong that it even pulls in light and it distorts matter around it and all this stuff. It's all out of the math equation being broken because they're trying to use it to describe something that it can't do. So it airs out. It produces a singularity, right? It's like equivalent to dividing by zero. It just produces nothing, right? Instead of going, oh, the equation is broke, it doesn't work, they turned it into this fantastic story, and they gave life to this entity called a black hole. And then not only that, if they use a different metric to do the calculations, the Kerr metric, for example, which accounts for angular rotation angular rotation and whatnot, then they have a rotating black hole just based on the collapsing of the mathematics used to describe the phenomenon. It's completely abstract. It has no physical value. So a way that you could think about a singularity kind of is if you were to, what would be a good way to describe it? So if you just hold your index finger and your thumb together, just kind of like, how close can you get them before they actually touch? Imagine that you could never get them to actually touch, and you could always just perpetually get them slightly closer but never touching. So that tendency towards zero, that singularity, that's the concept of a singularity that they're describing, that's breaking space-time, that's causing this infinite curvature and all this stuff, that they're attributing all this stuff, right? It's just pure abstract mathematics. And that's a hard one to let go, because black holes were cool as hell, and we got all these awesome movies and all these Event Horizon. Black holes are the shit, man. It was a tough one to let go. But yeah, it's literally
is a fun one.
Yeah, Interstellar. Yeah, it's literally just a math story, and then based on which math equation you're using to describe the phenomenon, i.e., which way you break the equation, determines what kind of rotating or stationary black hole you get. It's bizarre. And then yeah, sorry, go ahead. You're good. I said a lot.
No, Alan, I just wanted to add on to that. Did you also hear about how that breaks the gravitational model for them? So now they have a galaxy rotation problem where the stars that are closer to the center of the mass are spinning in the same velocity of the ones at the edge of the galaxy. Well, that's a problem, because if that's they fixed it with dark matter, but if Ken had a great presentation, shameless plug. It's pinned to my page that talks about modus ponens, which I will and how that relates to scientific testing. So if the gravitational model is correct, then the galaxy rotation problem is the antithesis, and it breaks it. And instead of just saying, like you said earlier, oh, well, this broke, we got to go back to the drawing board, we create a whole nother theory. It's like a Hegelian dialectic. It's an antithesis of it. We're just going to create a whole new synthesis of that. So have you found a lot of that where it's like a win-win situation where you get rid of a null hypothesis by bringing it into another theory? And if so, share, if you share that, please.
Shoot. Let's see here. I'm sorry. What was your question? It was
the galaxy rotation problem. Do you see that they're trying to fix gravity, like the problem with broken gravity. If their gravitational model is correct, then the galaxy rotation problem breaks that. So they got to invent more dark matter. Well, that just negates your null hypothesis. You have no more null hypothesis if you can just say, well, dark matter that we don't measure yet or see yet, touch yet, we
Oh
can't.
yeah, dude, it's insane. It's insane that they did that and nobody called it on them, and now that we're calling it on them, they act like we're retarded for for questioning it. It's actually insane. No, you're dead right. So the galaxy rotation, based on the because this is what they do. They look at a galaxy, right, and they go, okay, it's this bright, so therefore there must be this many stars in it. They do this whole mass distribution thing based on the luminosity or the magnitude of how bright it is, basically, right? They're just they deduce it all back to that with their noble ladder and stuff, right? And they found that based on their assumptions on the noble ladder, which is how they're deriving how much mass should be in a galaxy to begin with based on its luminosity, right? So they found galaxies that weren't as bright and they were spinning too fast for how much mass they should have had or whatever. So they said, oh, so naturally the galaxy shouldn't have been able to support itself and it should have ripped itself apart, but it didn't. So that's where they came in with an unfalsifiable claim that there's something out there that doesn't interact with the electromagnetic spectrum, but it somehow facilitates acceleration and deceleration to the point where it holds a form in place of mass, even though it doesn't interact with light in the way that that would be meaningful, that would enable us to see it. So in regards to that, right? So check this out. They say that so dark matter, essentially what they're saying is that dark matter only interacts with the gravitational field. Okay, cool. Only interacts with the gravitational field. That's great. So that would also affect the light. That would also affect like gravitational lensing and all that kind of stuff. So there would be indirect effects of dark matter that we could see other than just the ad hoc explanation of the galaxy rotating faster. There would be additional effects that we could see, that we could analyze, that they can make predictions off of with redshift and whatnot. Because if it truly is affecting the gravity field in that way, well, guess what, dog? Einstein's whole theory is based on gravitational fields. You should be able to reverse engineer exactly how much dark matter is in that area that's facilitating all that, and then you should be able to confirm that through spectral readings. And they never do, never have, never will, and they just say it doesn't interact with light, but it does interact with the gravitational field by the way that they're describing it. And the gravitational field in their model in their belief system interacts with light. So where's your spectrum shifts at, lads?
And if that gravity is stronger than the black hole center itself, and that can cause Hawking radiation, what the fuck is going on with dark matter? That should be all kinds of weird shit going on with light. So everything they fix something, they break something else with that fix. And lastly, I just wanted to put two things up in the next. I don't know if you ever heard of Hatch, Mr. Hatch. He goes into electronic theory conferences along with Steven Crowther. I don't know if you ever heard of him as well.
Mm-hmm.
So yeah, that goes into what you were talking about with the relative observer effect with the GPS. He's actually a GPS expert.
Mm-hmm.
So he deals with it. Ron Hatch, if you ever heard of him.
Yep, I got his book. It's
oh, you got his book.
Yep, Escaping
nice.
Einstein or something. Yeah.
Sweet.
Yeah, if you want to check it out, it's pretty decent. It's got some good stuff on there in regards to the Sagnac effect.
Dope. Cool, man.
But yeah, he's got some interesting stuff to say about gravitational fields. He actually has his own ether theory too, but I haven't really read too much into it. But yeah, he had a whole thing going on. I think he might have died recently. Peace be upon him, if so.
Hey, just real quick, just a shout out, Mr. Xavier's doing a Sunday Space Standard Forum. In order to grab a mic, you have to stick to the protocol, stick to the etiquette. And what is it about critical thought and coherent arguments, Mr. Xavier?
Yeah, it's just real quick. I'll make it 30 seconds. It's about standard form arguments. A lot of times when we have these conversations, we end up talking past each other a lot. So again, shameless plug. My pinned tweet has the space is 1 hour. Ken talks about some of the rules of inference you talk about when you engage in these conversations, engage in logical inference, and how do you formulate an argument with that. If Mr. Xavier has an XY chromosome, and those who have an XY chromosomes who are adult are labeled men, and Mr. Xavier is a man. Simple, clear, concise format. If those premises are true and it leads to a conclusion, then these conclusions are automatically true. And why would you want your arguments to be automatically true? I think those come in handy, right? It's pretty important. So if you learn how to put them in standard form and their sound, they're really cool. So I'm going to do a format with just that. No free form conversation that goes all over the place. You stick to one premise. We don't get off of it till we finish that. So yeah, thank you for that plug.
Yeah, I've been over there. It's a dope conversation. So looking forward to it. Still Flash Sundays, Standard Forum Sundays, Flat Earth Fridays, and we pushing into stationary Saturdays. We rocking. Still tapping in the ether with me, Proud?
Yeah, you already know I'm battling the mention bots.
Oh, no
Now
way.
it's active. They ain't in here. Hey, yo, Bradley, call eye level. Call Yuval. If I do it, he gonna say I'm antagonizing him. But you're a Glober. Go get your backup.
Yeah, Bradley, Peter, go get your guys.
Oh, and Conspiracy Smasher. He been crickets since
No
12
way.
hours. 12 hours this man been crickets.
Not
He
the Conspiracy
commented
Smasher crickets during Flat
under
Earth Fridays.
commented under Ted's repost of the space to talk shit, but never pulled up. So yeah, I'm sorry. I'm doing recon, guys.
been on us all week, too.
Appreciate it. Intermission. Brief intermissions coming soon. Stationary Saturday reset.
Yeah, I'm looking at this astronomical algorithms that I got to via the NASA website that Alan linked me to. It's over 400 pages long, and the chapters that have to do with eclipses are chapters 2, 3, 7, and Appendix A and B. And there's a Fortran program too. So there's a lot to go through here, but I've been looking through it, and I quite honestly, Alan, I don't see anything about what you're talking about. Every formula, every process that he's talked about so far has to do with a globe Earth. So maybe you can point me to a particular page in this thing that would help me understand. But it's going to take a while.
Yeah, no worries, man. I don't have a specific page for you.
My bad, guys, tweeting over here. Who was up next? Did we? I think it was Liliana. Go ahead, bro. You kind of choppy right now.
Who's up?
Oh, I want to make sure I can hear. I just want to make sure I can hear Proud. Proud, you
Can you
mic
hear
good?
me? Sorry, I don't know who's up.
Oh my goodness, ladies.
Who's speaking right now?
Go ahead, Lily.
It's on you, Lily. It's
Oh,
on
okay.
you.
All right. Can you guys hear me? Sorry. Can you hear me?
Loud and clear.
Okay, cool. Yeah, I wanted to answer that question that gentleman had who was talking about the sunspots and whatnot. So yeah, I just wanted to tell you that, I know that you were talking about having all the instruments and how, yeah, I think that we honestly, not we, but I think globe earthers totally believe in the infallibility of instruments like telescopes and things like that. And they're not infallible, okay? Because at some point they could make mistakes, so we wouldn't know. So they could be right 90% of the time, they could be right 80%, 99%, but they're not infallible. So I just want to convey that. And then the second thing is that I think that, to think that the ancients knew less than us is really not fair, or I don't think it's even objective, because A, we don't know what they really knew or didn't know. But B, you have to really open up to the idea that they might have had way more common sense and also just ways of deducting things. Because I believe that we're really dumbed down. I think that the ancients were inherently just naturally more intelligent. They knew how to use critical thinking better than us. Their pineal glands were not calcified with fluoride like ours are. So let's not think that the ancients didn't know. As far as I can tell from what I know of my own history, of my heritage, which is Vedic, and it's super, super ancient. These are people that invented the zero. These are people, the Sanskrit language is supposedly like the most ancient language that is the ancestor of all the Indo-European languages, et cetera, et cetera. And my point is that they were avid astronomers. They completely accurately have been predicting eclipses for thousands of years. There are books there that are thousands of years old. And just because Western scholars say, oh, this was written, 1,500 years ago, that doesn't make it true, because they have been keeping time by the constellations. Excuse me. And so you don't make mistakes. If you invented zero and you're keeping time by the constellations, you definitely know the difference between 100 years and 1,000 years. So my point is they knew a lot. But anyways, going to the sun, having the sunspots, according to the Vedic paradigm, and actually to get into how they came to this conclusion is a little long, so I won't give it to you. But what you can know is that, astrophysicists of today have told us that several stars, like magnetars and, various kinds of stars, they're some of the most electromagnetically powerful items that they've ever seen in the universe, right? So basically, there are stars that are beaming out incredibly powerful rays that, according to the heliocentric science, the regular, astronomy today, they're light years long because they're that powerful, right? Because they measure the power or whatnot. Anyway, so let's just say that they're very powerful beams, right? So now, if you think that all the astronomers, especially the ones in university, are just able to go and have time on these multi-million-dollar telescopes and just go and check out anything that they want to check out, that's not how it operates. They have to have very specific permission to which the computer will be, aligned to that particular part of the sky that they are allowed to explore, et cetera, right? So it's not like the astronomers and astrophysicists of today have free range, to just go and explore anything they want with those multi-million-dollar telescopes, which, by the way, are not completely infallible, I'll remind you. So basically, as far as the Vedic paradigm goes, and as I said that, it's too long to explain, so I'm going to try and write it down at some point and present it to you guys. But here's how it works in the Vedic paradigm. So yes, the stars are shooting out, various stars, multiple stars are shooting out very, very powerful beams. And in fact, all the luminaries, all the planets, quote unquote, including the sun and the moon, are all a result of these beams that are shooting out from various stars in the sky, in the dome, that come together at certain points and create these luminous orbs, which are basically plasmic in nature. And each of these orbs are at a different altitude within the dome. So you have to think of these layers, dome-shaped layers of their mixture of various gases and force fields. And depending on which band or which layer of the gases and force fields that these stars are going and merging their beams, a different orb is going to be created. So the moon's layer is the highest according to Vedic astronomy. And then right below the moon's layer, which is, hundreds of miles wide, right? The layer, if you had to just measure the altitude of the layer, it's hundreds of miles wide. And then underneath that layer is another layer of gases and force fields. And that layer is where the sun operates. Now, we're not talking about the horizontal orbit. We're just talking about the altitude of these gaseous and electromagnetic domes within which these orbs are moving. So literally all the luminous orbs are tethered electromagnetically to various stars in the sky. And actually, the Vedic astronomy even tells you which stars are tethered to which planets are tethered to which stars, which I'm not going to get into right now because it's all very long. But basically, that's how it is. And so to explain the sunspots and just the way that the sun is, you can just imagine if there's various stars beaming those powerful, invisible radio beams, because it's in a frequency that we cannot see with our eyes. And if they're being seen by some radio telescopes, we're not being told about it. So if you think that, all of astronomy and everything that they see through these various exotic instruments like radio telescopes and stuff, if you think they're actually telling us everything they see and they know, then I don't know what to tell you, because they're not. A lot of it is hidden. So we're not the first people to, to understand all this or see all this or to have technology to do all this. But basically, if you look at all the luminaries, they're all moving along with the sky dome. And if you start drawing lines to these stars, once you get the names of them, you will see that they're literally electromagnetically plugged in. So what you're seeing in the sunspots is a few spots here and there that, the beam is not there. And so it translates as being dark. But it's just because that portion of that layer of gases and electromagnetic field is not completely lit up. So anyways, that's kind of just the short version of it.
Can I respond? Can you all hear me?
Yes, sir.
Yeah, go ahead.
Oh, okay. Thank you for that explanation, Liliana. That's way over my head as far as that theory goes, and I'm curious to read a little bit on it. If someone can point me out to some literature, I'd be interested just to look at it. So yeah, I don't really care what scientists are doing with their big expensive telescopes. Really, I'm really interested in what all of us can do with our budgets in purchasing a simple, let's say, a 4-inch Newtonian reflector telescope, which contains no electronics, it's just mirrors, attaching a simple camera to it, an astrophotographic camera, and collecting some images in a series, and then seeing what we can see. We've all seen animations and videos of the sun rotating and whatever it is that scientists put out there. And we can all, fairly assume that, well, anything can be faked when you get down to it. It's just like the phrase, anything's possible. So we can all kind of wave that away. That's fine. But I'm really excited and interested in what all of us people as citizens can do to confirm or disprove some of these things we've seen. That's all. And I wonder what we would see if we did that.
Can I give a real quick, tiny response to that? Hello?
Absolutely. I
Oh.
grant you permission. You're good.
Sorry. Yeah, what I was going to tell you was that, I think that, we definitely, that's a very good idea, what you just shared. But my point is that you still cannot completely trust what even your eyes see, because there is something called optical illusion, and there is something called, from different angles, things are going to look different. So like, we were talking about earlier is, someone in Italy might see things slightly different from what you see. So that again is not a complete guarantee, but the idea is good because it'll get us closer. So yeah, you're right.
If y'all good, then Peter, you can jump in here. Trying to
Yeah,
get some
thanks. I was going to say a few things about the black holes in reference to what Alan and Xavier were talking about, but I think
go
we may
pushing
have
no
drifted.
propaganda on the audience, Peter. Come on, bro.
Oh, okay. Then I'll go
Go
on
ahead,
mute.
bro. Get your black holes off.
Okay. So one quick comment. I think it was Lilana that said infallibility of instruments. Like I don't know of any scientists who would claim that. Actually, to the contrary, they're kind of obsessed about always taking into account the errors that their instruments produce. If we're lucky enough to have Franco here tonight, I'm sure as a particle physicist, he would tell us all about that. So a few things about black holes. In general, I agree with the overview that Alan gave. I would just a few remarks. So like the math does break down, but it breaks down only in the very, very center of the black hole near the singularity. Inside of the black hole, away from the singularity, the math is known. And outside of the black hole, it's totally known because there's nothing special about the black hole outside of it. So basically, the way you can imagine it, you can do this thought experiment. If I'm talking about the heliocentric model, so you'll have to bear with me. If the sun were to magically become a black hole instantly, nothing would happen to the orbits of the planets because the mass of that black hole would be identical to the sun. It would be much smaller, its surface, but the mass would be the same. So the black holes and the problems we have with them mathematically in the singularity do not cause the problems with galaxy rotations that Xavier was talking about. The problems come from something else. Basically, it seems like there is a lot of mass that we don't see missing. And that is the problem that doesn't account for the movement of galaxies, not the black hole. And to solve this problem, we introduced the concept of dark matter to kind of compensate for that missing mass. Furthermore, dark matter is measurable. We have estimates of how much of it is where because we derive it from the equations and observations of the galactic rotations. We just cannot see that matter itself, hence dark matter, and we don't know what it's made of. All right. And that's what I'm almost done. I'm almost done.
You guys heard that, right?
I am almost done. And so we don't know what it's made of, but we know how much of it there would be if it existed, right? That's what the model predicts. And one last statement.
You said if it existed?
No, it's only in the model. No, it's only in the
it's
model.
only in a model. Okay.
Of course. We don't claim that something exists if we cannot describe it using the standard particle model, right? So that's what some people that I even know are trying to discover, but they're not there yet. And they might fail also. And then the last point I want to make before I bore you to death, we don't observe gravitational lensing from dark matter because lensing occurs when you have a lot of matter concentrated in one place, like a large star or a black hole. Dark matter is somewhat evenly spread through the gaps in the galaxies. That's the hypothesis. So it doesn't bend the light because it's not concentrated, and it doesn't seem to interact with electromagnetic waves. That's why we cannot observe it. That's why it's dark. So that's the concept of dark matter as it currently stands, and I hope that helps. Thanks.
All right, I'll jump in first, and then Alan can, since he addressed both of us. But that's the problem. You can't. What Ken went over last week was something called affirming the consequent. You can affirm the antecedent. This is part of logical deduction, or you can affirm the consequent. The affirming of the consequent is a logical fallacy. I mean, you're presupposing something. When you're presupposing something, that's not measuring something. You're saying, shit, my thing is going to be wrong if I don't presuppose there's something with mass here, because these stars are not supposed to move. And you misrepresented what I said. I said the stars are the galaxy rotation is a problem. The rotation itself, based on the center of mass. So I didn't say it was the black hole only, because of how the stars are moving is a problem. So hence, you got to inject energy with mass that's not there, hence dark energy and dark matter. Second of all, you cannot run a hypothesis test without a null hypothesis. Your null hypothesis can't be if stars do not rotate in the way that they're rotating, then no dark matter. No. It doesn't work that way. You have to measure, vary, and manipulate the dark matter itself. And then you isolate for that to see if the stars, and obviously you can't do that. So you're in a bit of a pickle. So let's not misrepresent what I said. There's a cause and effect method to this, and you cannot do this with astrophysics. Alan, I don't know if you wanted to add to that because he did address both of us.
Oh yeah, I wanted to say thank you for the clarification on the black hole and rotational clarification, because the subject was kind of mixed together with what dude was saying. So thank you for clarifying that. And then also in regards to the interaction with dark matter, so it would affect the gravitational field, right? Because it's all what it's facilitated by. And if the gravitational field is affected, then there would be spectral readings to correspond with that amount of missing mass for the gravitation, right? So they don't have those.
Well, yeah, but when mass is spread around, like we have the Oort cloud on the outskirts of the solar system, it doesn't gravitationally lens in any observable, or it does in very minute ways that we cannot measure. But we, in our ability to measure gravitational lensing, requires a significant mass in one place to observe it. So in the generic case, every single atom creates gravitational lensing with its mass, but it's so minuscule that you don't see it. So if it's spread around, you don't see it. If you put the same atoms all very closely together, when you pack them, it creates a large deformation to time-space. And that's why we observe gravitational
So
lensing.
if the overall mass of the galaxy is being held together from dark matter, that missing mass distribution, the light emanating from it will be spectral shifted, corresponded to how much gravitation is.
Yeah, but it doesn't.
Is there,
right?
But it doesn't. So it just shows like
Yeah, it doesn't.
shit. So like
that's why we call it dark matter.
Negative.
That's the only reason why we call it dark.
Negative. You're not understanding. So the gravitational field, right, is what the mechanism for relativity to facilitate the wavelength and the frequency change for light, right?
Mm-hmm.
And the dark matter is altering the gravitational field such that it is facilitating acceleration and deceleration within the system, so that it does not rip itself apart. Thus, there is some sort of mass there that is completing the gravitational field for the system. Yes or no?
No, actually, yes and no. So if I take the mass,
can't be both.
Okay, so no. So I'll go with no, and then I will explain. Is that fair enough?
Sure.
Okay. So if I take the sun, which has significant mass, and I break it apart into individual protons, and I spread them over a large area, it's the same mass, but the deformation to space-time that it causes, it's minute in every little part of it, right? But if I take the same mass and I pack it into the size of a peanut, which would be, black hole would be like, I forget how big for the sun, like 30 feet maybe. If I pack it tightly, then it's going to deform space-time in that spot very significantly. So when you shoot light through that deformed space-time, so to speak, then you're going to see lensing. You're going to see it bend. But if you shoot it through a wide empty space where you spread around the photons of the same mass, you're not going to see that.
Yeah, so your analogy is slightly off though. So the way that you would be, the way that you kind of describe it would be, you have the sun as individual particles, right, separated over a wide area, and then there's nothing in between those particles, right? That's not the case here. So in between the space for each particle, there would be the relevant stars of the galaxy, right? So it would overall facilitate, the missing gravitational force in the way that would change the spectrum of light to correspond with that amount of density in the system, right? So like it's not there.
Well, you wouldn't, because it's roughly uniform there. So when the light travels, us humans wouldn't be able to tell if it's affected or not, because there is no visible dent in time. If you imagine time-space being kind of compressed or dent in it caused by concentrated mass, and we see it only when the light traverses that spot. It kind of bends over it. When this mass is spread over, we don't have like a reference because it's all smooth. It smooths out, we would say mathematically.
So based on the luminosity of the galaxy, right? They get their mass of it, right? And they can take spectral readings from that. And
That's right. Yeah.
And they can deduce how the light is interacting with the gravitational field as it's escaping the system. And if there were a dark matter, interacting with a gravitational field such that it is causing the acceleration and deceleration, it would affect the spectral readings, and it does not, sir. Therefore, there is nothing that is facilitating this extra acceleration and deceleration required to replace the gravitational density that would be required to hold the system together. It's a very simple. Yeah, that's what I'm going with now. It's a very simple, logical, deduction. It's nothing too crazy, right? Like the spectral readings reveal it all. Otherwise, you would have to argue that the gravitational field doesn't interact with light in the way that we think it is, and then in which case we'd have to rethink all the so-called proofs of relativity.
But so it's two different statements to say that mass interacts with space-time, which it does.
Negative. The gravitational field.
Well, okay.
Peter, this is a perfect example of what you did last Sunday when I presented standard form. When you now know, Alan, you did such a good job presenting that quick standard form argument. Boom, boom, boom.
But I'm debating his argument. So,
but you're not though. You're just speaking past him. Why don't you present why one of his premises is wrong, why it doesn't entail?
Thank you. So I will present my own standard argument. Okay, is that fair?
Absolutely.
Why don't you try to refute one of his premises?
Because I think he's wrong, so I won't.
So which one of his premises is wrong? Which one of his premises is wrong? And refute it that way.
Okay, thank you. I appreciate that. Here is what is wrong. He correctly states that mass.
What you think is wrong.
Yes, what I think is wrong. Thank you very much. Mass, he correctly states that mass affects time-space. Yes? And then he assumes incorrectly that means that no matter how the mass is distributed, there is an observable, for us humans, gravitational lensing caused by that deformation. And I propose, Xavier, that those effects are observable to us when mass is concentrated enough in a particular spot. And then when we observe light traversing that spot, we can see the lensing effect. And for reference, I will tell you that we can see lensing caused by the sun, but I think we can see it caused by the moon, I may be wrong here, or smaller objects in the solar system, even though we see them and we're close, but they're just not massive enough. Does that make sense?
Okay, so.
But you did not listen to him. You said, okay, so take a boulder and then smash it into little rocks for an analogy. Your analogy is that rocks spread all over the place is going to take up less density than that giant boulder. But what he said is that space between those rocks is the stars and everything else that he mentioned to fill it up. So it would be that boulder that would take up the density. I'm paraphrasing, I'm oversimplifying it, but more or less it's
that's a good one. Yeah, it
so
is
you
correct.
ignore him,
I
you
like
ignore
what
his
you
premises.
No.
So why don't you address what he actually said and your false interpretations?
I will actually address what you just said, which I think was a very good illustration of that of claim.
Well, why don't you ask Alan if that's a good representation or a good?
Not only is it a great representation, it's verbatim what I said. Anyway, continue.
Thank you. We can agree on something now. So when we observe light traveling from somewhere in the universe through that space where these little pebbles are spread roughly evenly and smoothly, we don't see it bending because it's the individual dents that they make are so tiny.
Sorry to cut you off. Forget the bending. Just analyze the spectral shift argument. Forget the bending. Forget the bending. Just focus on the spectral reading.
Like the shift in wavelength?
Yes, facilitated by the gravitational wave change.
Well, we don't see the part of it caused by that, because a much bigger part of the shift is caused by the movement in the universe itself, such as expansion. Everything's moving in relation to us, so absolutely everything is shifting. And the factor that such tiny pebbles evenly spread around would introduce would be insanely small. Like, how would we know what is from what? We're already estimating crudely what the shift is from the speed of the expansion, which is also estimated. So how would you account for like such tiny differences caused by individual tiny, let's say, particles, whatever they are?
Well, first of all, the entire entire mass was added to a galaxy to facilitate it not ripping itself apart. So like I wouldn't do anything to do that, right? So when they take their readings, they can analyze how much spectra shift should be there based on the what's it called, the luminosity of the system, right? So based on all their assumptions, the luminosity doesn't reflect a system that has a greater gravitational density due to dark matter influencing it. Now, I don't know if you're like intentionally not getting it or what, but at this point, it's kind of getting
I'm trying to.
It's kind of getting annoying. So, as dude said,
well, welcome to my world.
The space in between the rocks is also filled. So the way that you're describing that side of the argument isn't. It's not. Sorry, that's not.
Fair enough.
It's not
so
helping you.
Yeah, that's fair enough. So let's maybe move to another topic. And one day, I estimate 20 years from now, when we have a solid theory for what dark matter is, then we will revisit.
Cool.
20 years?
Sounds good. Why don't we make it 150? Why don't we make it 150 years?
It could as well be.
Yeah.
It could as well be. We don't know what we don't know.
Yeah.
Cool. Geocentrism doesn't need dark energy and dark
matter. Was there another question from another member of the panel here?
We actually do got two other globe earthers with their hands up.
Oh yeah.
Did we hear from who was next, Jonathan or Bradley? My brother, I was tweeting. Trying to get the toxic ones in here.
Bradley.
Go ahead, Bradley. What's up, bro?
Oh, Jonathan can go because I'm
still researching.
No, I've got questions for Alan, but I'm not sure if you want to take the conversation in the direction.
I mean, you have the floor right now, man. If you want to do your thing.
Okay, so Alan, these screenshots that you sent me and you put up in the nest are kind of interesting because they talk about all the ways that you have to kind of the process that you have to go through transforming things from the different coordinate systems so that you can eventually come up with a path, that you can plot on a map. And the first thing that I would note is that it's, as I look at it here, all of these formulas use a fair amount of trigonometry. Is that true?
I would assume so. That's what the supplemental or ephemeris is based off of, essentially. It's all just planar trigonometry. Oh,
you have to be more specific, Bradley.
Sorry, I had my mic muted. Yeah, I would assume so. I would assume a lot of it is because that's basically what the supplementary ephemeris is or whatever. It's all planar correction angles.
Okay. So in order to come up with these plots on a map, NASA uses trigonometry, right?
I would assume so.
Yeah.
Well, Fred Aspernak does.
Right. And did the Babylonians and did the Mayans have trigonometry?
Don't think so. I'm guessing by the tone of your question, they didn't.
Yeah. So that's the basis for my statement that the Babylonians could not possibly have produced the kind of results that NASA produces today.
So did they have geometry in the Babylonian area? Were they able to make squares and triangles and circles and such, as the
Yes,
Greeks did? Well, that's
Yeah,
exactly how the Greeks did the same situation.
the
So
formulas that you gave me,
Mhm.
formulas that you gave me, and everything that you admitted up until you realized where this was heading, says that NASA uses trigonometry. You admitted that, okay? The Babylonians didn't have trigonometry, so the Babylonians could not have done what NASA did.
do you
Okay, this
think
is just
drawing a tangent for
They did utilize.
trigonometry proves a globe or a
No.
plane either way?
I mean, you can try and weasel your way out of this, but
It's not a weasel.
I think I'm done.
Actually, brother, you're being a bit fallacious because no one said that they did exactly what NASA did. I don't think that anybody said that the ancients did exactly what NASA did. You're creating a straw man argument. What we said was that they derived what they know now from them, and they were flat earthers. That's
Prove
what
it.
we said.
Prove that they
What you
derived.
mean? This,
that
huh?
we derived. Okay, you just made a statement. Okay,
bro, this is the globe earthers are saying that they use a cycle. This ain't flat earthers that saying that they're using a cycle.
No.
These
You
are
said-
globe earthers that we getting this from. I tweeted it out. We gave you the information. We already went over this. This isn't flat earth information. I mean, it is technically, it's derived from it. But these
You
are
made it-
globe earthers on national TV saying, hey, this is how we do this. We get it from those guys over there.
That's not what Alan gave me. Alan gave me the formulas. Okay, those formulas are not the cycle. Okay, he's the one who posted them. So if you think that NASA uses the cycle, you have an argument with Alan, and I'll let you two have.
Where they're all derivations.
I'll let
That's the
you.
point.
They don't. What do you mean derivations? What do you mean by derivations?
The Babylonians' observations were mathematical and arithmetic based.
Yeah. What's your point?
You saying that you?
That was the whole argument, Bradley.
Let me walk through it slowly. Okay. Today, NASA is able to produce very specific, detailed location information and time information about where the path of the eclipse will go. I asserted that the Babylonians and the ancients never had that ability, and you guys disputed that. And Alan provided proof saying, look, this is what NASA is doing. And I pointed out that the formulas that he gave used trigonometry, which the Babylonians didn't have. So you are wrong. Okay, now this is not a question of whether or not the Earth is flat or spherical. This is a very tiny part of the discussion. And this is an interesting moment for you guys because it's very clear that you were wrong. You made an assertion that the ancients were able to do what NASA does today, and that assertion was wrong. And the question now is, are you going to admit it?
Where did NASA get their information from based on whose data that was collected over the years in the past? NASA didn't formulate all this. They got these predictions that they say they predict from a previous civilization.
Also, can I read this out in Science Direct?
The Babylonians discovered exact sexagesimal trigonometry.
So at least 15,000 years before the ancient Greeks discovered trigonometry. So your affirmative claim that they did not seems to contradict this source I have right here. And I'll be able to post that in the net soon. But see, this is what I'm talking about. If somebody says that an ancient civilization can predict, and you're saying a newer civilization can predict to the nanoseconds, nobody's negating that prediction is available. You're just complaining that it's not to the nanosecond. Who gives a fuck? The Babylonians discovered sexagesimal trigonometry. You are wrong, sir. 15,000 years before the ancient Greeks did. I have a source here. So you're just asserting things without any source. You're asserting another negative claim for somebody to bring a positive one. So I'm going to post that to your DM. And once you're wrong again, I'd like you to apologize to the panel.
And for a cherry on top,
Okay.
the Before the Babylonians, it was the Mesopotamians that were also flat earthers.
You misrepresented what I claimed.
Yo, hold on a second.
What I
Bradley, 'cause
claimed
I just wanted to
had
say
nothing
one
to
thing.
do with
Yo,
a
Bradley.
more precise timing. What I said, and I'll say it again just so you understand what I'm saying, is that the Babylonians and the Mayans and so forth, they could predict the time of an eclipse.
Yeah, but
They
you're wrong,
could
Bradley.
not
They also had
predict
trigonometry. They
the
also had
location.
trigonometry.
They
They
could
also had
not predict
trigonometry.
the location.
From
Okay, and it's
Okay,
ScienceDirect.com.
you're
location.
changing your
Yo, excuse
argument
me.
now. You're saying
No, I
that they
am
did not
not.
have.
This is
Yo.
what I
Yes, you
said.
are, Bradley. Don't raise your
Space
voice at me,
recorded?
boy. I'll put you in the corner. I'll make you
Is
kneel,
this
boy.
space recorded?
Don't you raise your voice at me, boy.
I'm not.
So sit your ass down,
I'm
boy.
not raising my
You gonna
voice.
sit your ass in the corner,
Someone
boy.
sounds kind of heated.
Yo,
Nah, I'm
You
Bradley.
laughing
sound
at you,
kind
boy,
of heated,
because
man.
you said
You
you
need to
don't have
calm down.
trigonometry back then, and you got
need to
proven
calm
wrong
down.
twice, boy.
Yeah.
I thought you said they didn't
Yo,
have
Bradley, it
trigonometry.
says right
And
here.
people just say, hey, by
It
the
says
sound
right
of your
here.
voice that you're probably right, but nobody said that they conceded. And you're wrong. I just took a quick Google search, and Babylonians did have trigonometry. So you're just lied, or you're wrong.
Hey,
That's what I
peace
was
among
about
the
to say.
Christians.
That's
Okay,
what I was
peace,
about to
peace,
say.
peace. I have a clarifying question, Xavier, because I want to do my own research here to
Yo, just
resolve this.
chill. Let Bradley finish,
I have
bro.
a question, but it's
Let
Bradley
Bradley.
will find it useful. You said that we have records or 15,000 years ago.
Excuse me?
Did I hear you correctly? You said we had records of the ancients from 15,000 years ago?
I have a source that says it's been, they have trigonometry at least 15,000 years before the ancient Greeks, according to anthropologists. Do you want that source?
No, I would love that. Yeah, because
Yeah, dude, I just looked at the website here. So when you click on the cycles or whatever, it's literally all serocycles, eclipses over the dude. This is nuts. What the heck did this guy even read?
Can you post it in the Jumbotron?
Old Babylonians used trigonometry in the 16th century. BCE.
16th century?
Yeah, BCE.
Oh,
I'm
okay,
sorry.
okay. No, that.
I'm sorry.
That's directed to
1500.
Bradley. That
And
was giving false
it's
info.
actually saying that they trace the origins of trigonometry to the old Babylonian era. So I don't know what the fuck Bradley's talking about.
Right. He's all
Yeah, I
over the
want to
place.
look into
He's
it.
just
Right.
making shit up. And also, Peter, just quick correction. I read one extra zero. It's 1500 years.
Got it. Thank you.
So Bradley's just making shit up as usual. But anyway, Alan, I have a quick question. So, you having fun, bro? It gets kind of crazy sometimes. But
Oh yeah, absolutely, dude. Absolutely. And real quick before we proceed on, so I don't know what you were looking at for the calculations from Fred or whatever, but on the NASA website, if you open up the data tables or whatever and just Control F Saro cycle, or Saro, you'll see like it's all of them have it, or a lot anyway, or the ones I checked 3 randomly. So like
yeah, Alan,
it's
they're
definitely
hoping
in
that
there.
we
I'm
don't.
not.
They're
Yeah.
hoping we don't Google when they say shit. They hope we say shit and hope we don't Google. So as you see, as I did and you did, we just both just dunked on them real quick. So it happens when it comes around. But yeah,
that quick mop up, dude. You know what I'm saying?
Man, the receipts is up top.
But it's all good.
Just in case you think that we capping. So how do we look at the same thing and then Bradley be completely wrong?
Because he
I
just
don't
be
know.
capping, like you said. He just be talking out of his ass. He wants the shit to be round so bad he's willing to lie.
He might have looked at like the final summation of what Fred is trying to say he does with his algorithm or something, and was like referencing that and not the source of all the summation of where the data came from. Because if you do that, like you'll see, it's pretty evident that they had all this stuff cycled and predicted out and mapped out and stuff. But anyway.
So maybe the truth is somewhere in the middle in this case. I had a quick look.
No, he's just wrong. I had a question first, man, please. So earlier,
you're welcome,
gentlemen. Talked about how some of the things that he saw with the stars kind of made him convinced about the shape of the Earth, where you pointed out that this can work on a separate model, that it's not mutually exclusive to one. But one thing that is mutually exclusive to the standard model or something alternative, possibly like an ether, Einstein's posit with the constant of light being a problem. He talked about what the hell is that instrument? Damn it! What is that instrument that you could see it going in one angle? Photographic plate, high altitudes. One way it goes, light goes one way faster than the other. You know what I'm talking about?
Yes.
Yes, thank you. I don't know the name of that instrument, but if you could explain to the newbie who asked, I forget who it was, of how that's a problem and how that can be mutually exclusive for their model being incorrect.
Okay, yeah, absolutely, bro. So in the case of interferometry, what they have or what they say is that the speed of light is the constant and it doesn't change, right? So when they do an interferometer, or what they did an interferometry experiment in 1887, basically what they do is they split a beam of light. It hits two mirrors, reflects back, recombines, and then it hits a photographic plate. Or in the Michelson-Morley apparatus, they didn't have a photographic plate. They were kind of like projecting it onto a screen and then marking the distance between the fringes and then measuring it out. But for modern interferometry, it'll be projected onto a screen as well. But there's different ways you can do it. But anyway, what they found was that the speed of light varies. There's a variance to it, and it should have corresponded to Earth's motion, right? So if the Earth is, if the heliocentric model is true, and then the Earth's position in the cosmos is that it's chasing the sun, right? So they would have had they had a predicted amount of fringe that was going to be proportional to how fast they were going, and they didn't get that prediction. So a way to interpret that in the speed. So in terms of the direction, though, before I get into that, we'll get into the direction of the alignment. So they had one of the beams of light in the interferometer was facing towards the north, right? And this would have been towards the direction of motion in their model, right? As the Earth is chasing the sun. And then they had an arm perpendicular to that, going out into space or whatever, right? And the idea was that this arm would drag against the ether, and there would be a variance in the speed of light, and they would measure Earth's orbital velocity through that, right? So they got a very slight fringe, not outside of their outside of their margin of error, but way outside of their heliocentric prediction. So they were like, "Oh shit, what do we do, boys?" And that's where the variance came from. So if you think about on a globe or on a plane, a disc, right? There's, you're gonna be, to circumnavigate, you're gonna be going in a circle, right? So that circle, east to west, electromagnetic propagation picks up a speed. It goes a little faster. It's like it's picking up a tailwind, right? So it's going a little faster. And then when it's going west to east, it's as if it's catching a headwind, and it goes a little slower. And the variance in that speed corresponds to the movement of the sun to the day on the equinoxes, where the fringe readings, right, reach their minimum and maximum dimensions on the day of the equinoxes, meaning that the speed of light is the fastest and the slowest on those days when it is traveling in the north and in the south.
Can I chime in real quick?
For the love of God, please do, man.
Thank you. Not to make an argument, but I did some quick research regarding the history of trigonometry. So it is true, per Xavier, that Sumerians and ancient Sumerians and Babylonians studied some properties of triangles. They have not developed a system for measuring the lengths of a triangle or its angles. So I'm not sure how relevant that is, but I would guess it is relevant. And only Greeks around 300 BC started developing deeper understanding of trigonometry. What is interesting, though, is that no other civilization, not the Indians, not the Chinese, ever developed anything related to trigonometry. So that's just an interesting fact. Now,
That
sacred.
is wrong. That
all right,
is
thank
wrong,
you.
Peter.
Okay, one last thing. A sacred permission to make a light-hearted joke.
Go ahead, man. Fire off.
Thank you.
Ego.
Thank you. It is a light-hearted joke. I am really happy that the major problem with the mainstream cosmology is the nature of dark matter, which is a big gap, big problem with it. While the problem with the flat Earth model is our uncertainty regarding the radius of the Tropic of Cancer and Tropic of Capricorn. That makes me feel like I'm standing on solid ground as a glober. Thank you.
Nice.
Don't slip along that curve. And we didn't say that's the only problem of the
Sacred. And may I, my brother, may I?
Yeah, go ahead, 40. Jump in real quick.
I have to. I've been in and out listening, and I have to speak. And I apologize to anyone. And it's fucking sad that I still have to apologize in 2023. I hear a lot of Sacred. I love you, my brother. Proud. Keep being you, sis. Alan, good to have you aboard. As a Mi'kmaq First Nations Indian, my ancestral's been on this fucking land since time immemorial. I can speak of ancestral knowledge of over 100,000 years on what you call America and Canada. So before anybody wants to speak about the civilization or what the science that you speak of what is written or by man, please understand and do not take this the wrong fucking way, because I'm getting fed up with most of society. I see a lot of very scientific people. I hear a lot of educated people. I hear a lot of very, very knowledgeable people. But I continuously hear a lot of Western colonial mindset of an indoctrination of brainwashing since most of society has been children, all written by man. The science that people are arguing about is written by man. That is not from this land we stand on. Please understand this. I'm not coming at any one of you. I love all colors and creed. There's no hate in me. But please understand that even Sacred, even Proud, even Alan, even Phantom, I don't want to call everybody else. There's even people in listeners, even Ruff. They're all speaking from an indoctrination that is not from this land. They're all speaking of history books and written books, scientific books written by man. Please understand, and I'll say this before we go to the next speaker, as a Mi'kmaq First Nations Indian from what you call Mi'kma'ki, which is Canada. Our people, long before any Western civilization came to this land of Turtle Island, which belongs to 3 continents and is First Nations land, whether anybody wants to believe it or not. My people, and I still do it to this day with my fucking hands. We built arrowheads in rectangle positions. Our teepees are a triangle pattern. Our wigwams are somewhat of a half sphere. We hand carved what you call beads today that you buy in your stores. We hand carved with our hands beads to make our wampum belt that are oval in spirit, and they have a hole in the center. Before your written works and what you believe in is only 5,000 to 7,000 years old. I sit down to this day with another First Nations brother of mine from Australia, and my elders are 120 to 125 years old, still living the way of my people, outside of society, healthier than an ox. So before you want to speak about man-made written science, man-made written fucking rules and beliefs, and don't ever think that there's nobody in Twitter Spaces that understands what walked on this land long before any of your ancestors. And I don't mean that in a bad way. But we have to understand, no matter what color, no matter what creed, we're all equal and we're all one. But in the last 3 years, my brothers and sisters from all walks of life, I don't care what you believe or whatever you think is right or wrong. Just open your eyes, step out of the fucking sandbox, and in the last 3 years alone, just imagine what they lied to us about. So imagine what they lied to our mom and dads about. Imagine what they lied to our grandmothers and grandfathers and greats and greats and greats. So I apologize for interrupting the last speaker, but I'm getting very fed up with a Western colonial mindset of Stockholm syndrome that's running fucking rampant in 2023. Wake the fuck up and pitter patter, my brothers and sisters. Let's get at her. But please understand, there's people in this space that know about knowledge that most of society has no comprehension of. Thank you, Sacred, Proud, and Alan.
on that.
Permission to address this gentleman.
We do not consent to get taxes and mandatory.
This is the brief intermission we were talking about. Thank you, 40, for that excellent. Follow anybody on stage that you resonate with. We've been going for some hours. Appreciate y'all for sticking in. You already know what it is. This is Flat Earth Friday. We transitioning into Stationary Saturdays. Brief intermission. Get a drink. Stretch your legs. Scream at the phone. Whatever you gotta do.
There won't be a rock and turn for y'all are behind it. You're unprepared for the upcoming uprising. And no denying that you've ruled for too long. And we're chipping away at your armor with each song. We used to treat the
Y'all still up with us?
Once you see what's to come, I wouldn't want to be in your shoes.
So the toxic globies is still awake. Tell them we still live.
World have no order.
Where they at?
Oh, dude, time flies by when it's Flat
Put
Earth
the
Friday,
keyboard
man.
down and pick up a mic.
4 hours and 20 minutes already. Seems like only yesterday. How we guys doing out in the chat? Everyone in here chatting? Dude, what up, Dave? Playing reality, what up? Andrew, what up? Yeah, it's dope, man. I like it. That fucking Peter guy is a straight vampire, though. Super fucking blood-sucking, man, with the most remedial dog shit ever. Like I didn't know that the stuff he was saying was like FTFE rhetoric or whatever, you know, like where's your hypothesis validated prediction? I like all that dumb shit that they don't do for the heliocentric model or relativity or anything like that. But like, you know, when it comes to the shape of the Earth, when it's a shape that they don't agree with, they're like, oh, you know, they have this rigid view of science all of a sudden. But yeah, that's hilarious, dude. This dude's a straight vampire, though. It's very soul sucking. How about your boy Bradley coming in hot with the Sarah cycles and then getting Sarah the fuck out of there? So there's 26 sections back and forth.
71 weeks.
Outer Ponders. Dude, Dave mentioned Outer Ponders. Dude, they're outer shellers.
I know you've been hating this, but how about that radius, huh? What is he saying though? Broken geometry. I just pointed out, now you're at hominy. Went to your mommy B. Clovers be wildin'. They went out of style. 8 inches per mile square. Never been measured out in the wild. Why would they lie? That's what they cry when it just can't be denied.
Hey.
Say till you die. You ain't got no reply.
Dude, Dave, hop in here and Outer Ponder these people, man. I think Peter needs to know about the Outer Ponders, my dude.
Hey, tell him it's still lit over here.
Yeah, I thought there were 28 sections as well, Dave. What the hell? How many sections are on a turtle's back? There are 13 scutes. One for each. Oh, that's not it.
They talking
it's
to
like
you, Peter. Don't take it personal.
A particular variation is the turtle. Wait, is it only a specific turtle that has 13? Oh, here we go. This is what I'm looking for. 28. So yeah, 28.
Why would they lie? Are you fucking high? You really gotta be kidding me.
A little bit.
All that you've known, all on its own has been nice and flat.
Not yet.
Well, no, it'd be more than that. So there's 28 here on the outer, and then 13 on the big piece.
So proceed to ask why they are lying without verifying your story. And at the end of the day, maybe all I can say is that y'all fucking bore me. Why would they lie? Can't even deny. You're sounding just like a baby. Maybe a hero is all that you need. Maybe else somebody save me.
Global abortion, all applauded. Cheers, big heads, small enormous. From